Welcome everyone. Now today we are on our week 2, which is the second module of this class. And today we are going to basically look at different Hadoop server roles and how to basically configure a Hadoop cluster, how to get a basic Hadoop cluster up. And we are going to look at what is the architecture of a Hadoop cluster, how do you read and write on files on Hadoop cluster. So we're going to look at all of that good stuff today. And so let's get started. So these are topics for today, basically. So we're going to look at various servers roles, that what are the roles of different components in the Hadoop system, which we discussed briefly yesterday. So yesterday was like mostly theoretical. So today we are going to actually do real setup. So that's where we'll see a real demo of how different components that we talked about yesterday work. We are going to look at HDFS architecture. We are going to look at MapReduce job execution. And then you're going to look at how a file is written on Hadoop and how do you read a file from Hadoop? How does it actually happen? What's the anatomy? What is rack awareness? Then we're going to do a Hadoop installation. We're going to look at mail Hadoop configuration files. How do you change the parameters there to get a cluster up? And what are the different cluster modes? And then we're going to look at some cluster architecture, how it looks like in production. And then we're also going to look at Hadoop multi-node installation and what are Hadoop clients. So it looks like we have a lot to cover today. So let's get started. So is like going to be the norm with every class. We are going to do a brief revision of what we did in the previous class, so that in case somebody didn't get a chance to look at the presentation or look at the things in the past day or past week, then we just do a brief refresh. So sorry. So this is what we basically discussed yesterday, that in Hadoop we have mainly two main engines. One is HDFS cluster, and then you have MapReduce engine on top of that. So HDFS basically cluster is your Hadoop distributed file system, which basically comprises of a master node, which is name node, and the slave nodes, which are data nodes. So master name node basically has the complete state of the system, state of the file system. It has metadata. It knows what are the blocks in the system. It knows how many data nodes are there in the systems, what is the list of files, where each file's blocks are residing. So name node has complete basically insight into the meta data of the system, and data nodes are the places where actual blocks reside, and they basically store the data. So that's the HDFS component. And on the top we have MapReduce engine, which is basically job execution engine of Hadoop, Hadoop 1. So in that case we have job tracker, which is the master again, and then we have task trackers, which are basically going to execute the tasks, which are mappers and reducers. So job tracker is the master and task trackers are the slaves in this case. So this is what we discussed. So that is a brief revision of what we did yesterday. So when I go to the next slide, then this is a summary of the slide that we saw yesterday. There's a client which is going from where you're going to basically query HDFS system, or you're going to run MapReduce jobs. So when you query the Hadoop file system, then your query goes to name node. Name node basically knows where the file is. So it will tell you the data node where the data is, and then you're going to basically, the client will directly go there and read the blocks. Again, we're going to cover this in detail today. And the nodes where data node is, on the same nodes we run task trackers, and task trackers run the tasks, which are either mappers or reducers. And job tracker basically is the controlling part of MapReduce engine. It decides which task tracker will run mapper or reducer based on the slots available on that task tracker, and it also monitors that uh, task tracker and basically sends the result back to the client once a job is done. So this is what we discussed yesterday. What are HDFS blocks? So again, we covered this yesterday also, but today we are going to discuss in detail. So whenever a file comes up, a file is always made up of blocks. When you talk of a Unix file system, the block size is really small. But when it comes to Hadoop, the file system would be a big file, and the file would be split into multiple blocks based on the block size of the cluster. So if you define your block size as 64 MB, then any file that comes to a data node, all these blocks will be 64 MB blocks. So if this file was, say, 128 MB file or 256 MB file, so that means it will have 4 blocks. So this file will be split into 4 blocks, and based on replication, there will be 4 times 3 blocks. So there will be 12 basically blocks for a 4 block file based on the replication factor. If replication factor is 1, you will just have 4 blocks. If replication factor is 3, you will have 3 different, as you can see, there's a blue colored blocks, there are orange colored blocks, and there are green colors blocks. So these basically signify the replication, and these blocks then end up on data nodes based on where name node decides to put the blocks. And the name node basically is now managing the complete file system, as we discussed. So there's a file system image, which is made up of the blocks in the system. All the data nodes basically tell their blocks. Whenever a data node comes up, it will tell its blocks to name node that I have these blocks. So all the blocks, for example, in data node 1, you can see there's blue, red, green colored blocks. So these are the blocks that are on data node 1. Similar, data node 2 has blocks. So whenever data node comes up, it will tell that I have these 5 blocks. So name node will basically make a note that these blocks are on this data node. And then it will have file system image, where it will basically know the file, and it will have the blocks, and from data nodes it will get the block report. So now it will know that which blocks are on which data node, and then that basically, that file system image plus this in-memory metadata from data nodes, which tells the block mapping to the data node, tells that name node clearly that where actually a file would be. And then we have something called edit logs. So whenever some change is done on the file system, a file gets removed, a file gets created, then we have edit logs. Like you have bin logs, for example, in MySQL. So based on that, we have these transactional logs, which are called edit logs. So basically, if you want to have the complete file system image at any point of time, what you'll have to do is you have to look at the initial FS image, which is the file system image that when name node came up, and then after that, all the changes that happen to the file system, they go under edit log. So if you basically combine file system image and all the edit logs that are present in the name node metadata directory, if you are combine them together, those together combined will tell you the file system state at the point of time, which is now. So basically, that's how the file system image is built. So again, we are going to discuss this in detail, but this is basically just telling you that what are basically HDFS blocks, where they are stored, and how name node knows where the blocks are stored. So Sanjay has a question. When a data node goes down, then the block info is removed from the FS image. So FS image basically is the image that came up. Yes. So as I said, there's in-memory file system metadata. So where whatever blocks are there on a data node, they are in name node's memory as a bitmap. So if a data node goes down, the name node will not receive any heartbeat, and then it will basically update those blocks for the data node as stale, and it will basically try to, based on your replication factor, for example, it was 3, and then say one data node went down. So all these blocks, the first blue block, for example, what is now replicated on 2 nodes only, this and this, the name node will start replicating this block to another node, and once it copies that block to another data node, then it will update that information in his bitmap that now the new data node, third data node for this block, is the new node where it just replicated it. So name node basically takes care of re-replication of the blocks in case a data node goes down. So hopefully that answers your question, Sanjay. And Syed is saying, is the default to 64 MB each blocks? So yes, so by default, if you don't specify block size on Hadoop, by default, it is 64 MB on all the blocks on the system. So basically all data nodes will store 64 MB blocks. So Fani is saying, can you come again? What exactly FS image contains and edit log contains? What is the default file size of FS image and edit log when we set up the name node? Yeah, so default file system size would be like very tiny, because initially you don't have anything on your file system image. So again, once I show the demo today, you will see that initially file system image would be like few bytes, because there would be nothing in file system image. So as and when you start adding nodes, the file system image will be built up, and then we discussed yesterday that secondary name node does some checkpointing. So when I said that at any point of time, if you want to see the state of your file system image, you basically combine initial file system image with the edit logs. So this combination, this merging of file system image with edit logs is done by secondary name node. So again, in our further sessions, we'll see how secondary name node does it. So basically, that's why I said that FS image is like constantly, if your secondary name node is running, it will constantly update that file system image by merging the edit logs at a point of time. And then those file system image will actually, if your secondary name node is running, your file system image size will keep on changing every hour, because what secondary name node will do is it will take the original file system image, take all the edit logs that happen in 1 hour, merge them together, and send the new file system image to name node, and the name node will start using that file system image, and all the edit logs that happen after are written in the new edit log. So every hour secondary name node does this thing. It will merges file system image with the edit logs and give it back to the name node. So that's why at any point of time, if you want to see real file system state, you have to use the file system image present on the name node plus the edit logs, because edit logs have all the deletes, the new mkdirs, all the new directory creations, also all kind of transactions, they go in edit logs. So hopefully that answers your question, Fanny. And so Fanny is saying, so it's like the data file and log file in SQL Server. Yeah, so it's like bin logs, right? So you have the transactional logs. So it's like that. So basically FS image is like file system image that initially comes up. So Sanjay is saying, when is edit log synced with FS image? So Sanjay, as I just explained this to Fanny, so I hopefully that answers your question, that every hour secondary name node is going to take file system image and take edit logs at a particular point of time or a transaction ID, and it marks that transaction ID that I have taken edit log till this transaction ID. So edit log basically has a transaction ID. So secondary name node will combine file system image and edit logs and send it back to name node, and the name node will use this new file system image, and then all the edit logs starting from the transaction ID till that the point where secondary name node has basically merged. So next time secondary name node will start looking at the edit logs from that new transaction ID that it saved at last hour. So that's how this merging happens. And again, we are going to cover it detail when we discuss secondary name node. Okay. So Mohammed is saying, can we change time of syncing? Yes. So by default, it is 1 hour, but you can definitely change it. Yes. So Hadoop is very configurable in terms of allowing you to change the parameters. So this is how basically HDFS blocks look like. And then we'll look at the HDFS architecture. We also briefly discussed this yesterday. So we are saying that client is the machine from where you are running Hadoop commands, file system commands to name node. So all the metadata operations to read data, write data happen from client, and client contacts name node. Name node is storing the metadata, which means all the files, and knows what is the replication of each file and what are the blocks made up of each for each file, and knows which data nodes have those blocks, and data nodes are basically storing the blocks, and replication happens across the data nodes based on the replication factor you have defined. And then you have multiple racks, so you might have one rack having few data nodes, second rack having few data nodes. So again, rack awareness is something we are going to discuss in today's class. So for your questions, rack awareness I'm going to discuss again. And then, so whenever client needs to read, basically it goes to name node, and it basically gets the location of data nodes and read the blocks from data nodes directly without talking to the name node. Similarly, when a client has to write, it basically talks to name node, gets the location, and starts writing the blocks to the data nodes directly without contacting the name node. So name node just tells them this is the nodes where you should write the data, this is the nodes you should read from the data, and then name node's part is over, because otherwise name node will be a bottleneck for everything. Everything goes through name node. So that's why name node just tells the location of blocks, and then clients, they talk directly to the data nodes to read or write the data. Anatomy of a file, right? So let's see how a file is written to Hadoop. So you can see this is like a flow diagram that has basically points which tells how exactly is things happening. So if you look at this diagram, we have HDFS client, which we are again saying the machine from where you are basically running Hadoop commands. And then you have a distributed file system, which is Hadoop distributed file system. And then you have name node and the data nodes. So first step would be that your data node is basically going to talk to name node and say that I want to write something, right? So it will just write a tell data node a create Java basically command, which on the background would be a Java API, and it will say I want to create a file. So that create call goes to name node, and what name node will do is it has in memory the bitmap, and it has what all blocks are on what data nodes and how much space data nodes have available. So in the name node will then it give him a list of 3 data nodes or 5 data nodes based on the replication factor. If replication factor is 3, it will provide 3 data nodes to that client, and if it is 5, it will tell it 5 data nodes. So what happened in this case is the HDFS client will now get the list of the nodes, and then client will now, so that would be step 2, and then at step 3rd, now the client has the list of data nodes and it starts talking directly to the Hadoop distributed file system, which basically are these data nodes. So at step 3, it will start talking to the data node and contact the first data node in the list, and it will go to the data node 1, and data node 1 will basically start reading that packet, and it knows that it has the rest 2 data nodes also where it needs to be written. So it will start writing the data, and it will inform the next data node that this packet is coming up, so you write this packet, and then next data node will again see that there's another data node that needs to write this block, so it will start writing this block and tell the next data node that okay, you also write this block because you are also supposed to write. So you can see that this is now a pipeline where all the 3 data nodes that client is trying to write to, it contacts the first one, that first data node then contacts the second one contacts the third one. So this is called a pipeline write, that when you write the data, it is like a pipeline, it goes in a pipeline, and once the last data node is done, it will give an tell this data node that I am done. This data node will tell I'm done. So now at this point of time, all the 3 blocks are written, and then they will basically send an ACK back to the client that we are done. So this client will now know that I am done. So it will then close this session with this file system to talking to the data nodes, and then it will send a message to name node that I am done, and name node will basically get updates from these data nodes also that they have new blocks, because data nodes periodically send the block information to name node. So whenever they write basically a file, they will tell name node, and then name node will then say that okay, now your create command is completed, and then the client will get the success back. So basically this is how a file system, how a file is written on Hadoop. So let's see what questions do we have on this. If no questions, I'm assuming everybody understood it. If everybody understood it, that's really great. Okay, so there's a question by Ryan. Does it mean that we'll never lose data on a Hadoop cluster unless the name nodes are down? Because even if the 3 data nodes that a block is replicated across are down, the name node will start replicating again. Is my understanding correct? So basically what we are saying is that Ryan, so what we are saying is, so your Ryan's question is, does that mean that we will never lose data on a Hadoop cluster if the unless the name node is down? That's true. But the second point that you are saying is, if 3 data nodes that a block is replicated across are down, the name node will start replicating again. Is my understanding correct? No. So if all the 3 data nodes where the block is basically present, and all those 3 data nodes are down, in that case name node and your replication factor is 3, that means only those 3 data nodes had that copy. In that case, name node does not have any place or any copy to replicate it from, because all the 3 nodes are not present, right? So in that case, the data is missing. So basically that's why your the copies of data is based on your replication factor. So if you lose one data node, 2 data nodes, it's fine. So you still have 1 copy, and then name node can replicate it and make 3 copies. But if all the 3 data nodes are down, then name node is not going to be able to replicate it, and at that point of time it will be the missing block. And when the file read, or when some client tries to read that file, it will get an error that missing blocks or the data is not available. So that's how it happens. So the name node can replicate only if at least one replicated copy is there. If no copies are there, then at that point the data loss has happened. Basically, till the time you don't bring those data nodes up, you won't be able to access that data. So Sanjay is saying a write request is also sent by client, right? So basically your file system is just a file system, right? It is looking at, it's doing its own thing of storing the data, telling name node. So basically your file system are all the number of data nodes in your system. They make your file system, and name node is basically looking at the state of the system. Data nodes are telling name node what blocks are. So they're just doing their own thing. So unless somebody wants to get some information out of them, they are not going to do anything. If a client wants to read or write data, that's only action will happen, that they will contact name node to write the data. Then name node will see, okay, I have these nodes available where data can go, and it will give those locations to client. So a write or read request or a job submission will always be done by a client, because name node is a server, and similarly job tracker is a server. So Shama is saying in this example, where is split happening? So Shama, split is not happening in this question. Split comes into picture only when you run a job. So right now we are just talking about reading and writing data, which is HDFS component of Hadoop. So when we discuss about MapReduce component, only then splits basically will come up. So splits will happen on basically when you say write a file and you copied 3 blocks. So those 3 blocks will become 3 splits, input splits for the job when you run against this file, and those 3 splits will basically run 3 mappers. So when we discuss our MapReduce engine in detail, that's when we'll discuss that how splits are happening. So Vani saying, so looks like client to name node, and name nodes given the data node details. Client contacts job tracker with data node details to write. So there's no role of job tracker. So that's what I just explained, Shama. So when you, whatever you see on this screen is exactly the components which are the players. So there is name node and data nodes, and there is client. So there is no job tracker. When name node provides a list of data nodes, this client will go directly to those data nodes, which is in number 4th. It is trying to write that packet. So this client is directly talking to those data nodes. There is no job tracker in between, because job tracker is only for jobs. Right now we are not running a job, we are just writing a file. And so job tracker component, Fani, you can keep separate. We'll discuss that, how job tracker will do this. Right now we're just talking about when data comes to Hadoop, how do you basically write data? So this is basically HDFS client. When you run, say, job, so this client, if you are submitting jobs from this client, then it would be called like a MapReduce client. So I was just looking at Fani's messages. So she is talking about job tracker. So I just explaining, as I just explained her, that job tracker is not in picture right now. Right now it's only name node, data nodes, and the client, which is HDFS client. So Sumati saying HDFS client here is HBase client. No, again, let's not confuse anything else. Right now, we are just talking about name node, data nodes, and a client, which is just trying to write or read a file. Nothing else is happening right now. So right now, we're just talking about how Hadoop distributed file system works. So once we understand this, then we are going to go to job tracker, Hive, HBase. So right now, we can basically think just about this particular scenario where we are trying to write a file and try to understand this. So we'll come back to all of these things as we progress on rest of the things. So Shripal is saying which component determines the data nodes? That is where the data should go. So that's name node, because when the data nodes initially come up, they send their block report to name node, and name node knows the cluster capacity, and it knows how much capacity each data node has. So name node decides that which data node would be able to handle this file, and it will just, it's on based on its internal algorithm. Whenever a request comes, it does that, and it sends the list of data nodes to the client. So Shama is saying when the file size is more than 65 GB, then who is creating block? So when a file size is more than 65 GB, so when you say 65 GB, that means it will be split into blocks of 64 MB. So what you can do is divide 65 GB by 64. So that's like almost 1000 blocks, right? So those 1000 blocks now, again, even if it's 3 blocks or 50 blocks or 1000 blocks, the same process happens. Name node will tell the client that these are the 10,000 blocks that you should write, and then the client will basically go directly to the data node and write those blocks. So if a file has say 3 blocks, so each block based on replication factor, it will write them the client will basically write them in a sequential way. And if it has 3 blocks, similarly, this is like first block and it is being replicated to 3 data nodes. Similarly, there will be a second block and it will be replicated 3 times. So basically, writing all those 3 blocks can happen in parallel, but replication of each block will be sequential. So this is how basically it works, because so that client can basically write the file quickly. If a file is basically made up of 3 blocks, the name node will tell first block should go to these 3 data nodes, second block should go to these 3 data nodes, third block should go to these 3 data nodes. So when client tries to write, it will try to write all these 3 blocks in parallel, but replication of each would be a pipeline, right? As we see in this figure, that each blocks writing of each block would be a sequential process. So Fani is saying, so a client has permission directly to write to data to DFS. Yes, a client will be able to write directly to DFS, basically, because name node does not do that. Because if client sends data to name node and then name node writes, you can see that how much network bandwidth will be used. Because then you say you're writing a 50 MB file, you first of all, client will send that 50 MB file to name node, then name node will write them to data node. So there's a lot of network movement, so we don't want that. So and then name node becomes a bottleneck, because name node has to serve multiple clients and multiple requests. If we start just moving this 50 GB data, somebody else would come another 200 GB data. So name node would just be moving data around and not doing the real work, and it will become a bottleneck. So that's why name node does not move any data. It will just tell the list of blocks, and the client will write to those blocks directly. It's client's responsibility. So Mohammed is saying, who should be in right should be in opposite direction. Opposite direction means, Mohammed, I couldn't understand. Okay, so Fani, do you still have confusions? It looks like you have some more questions. Yeah, looks like I was saying you she, but I'm wrong. I'm sorry about that. And Varun is saying, doesn't the files can be run by by the bad jobs? Doesn't the file can be run by bad jobs? I'm not sure what you mean by that. So, so right now we are just discussing that, okay, when a file run comes to name node, how name node does. But if you have, say, a batch process like a cron tab or something which is constantly writing the files, so this process will be done for each such file. So we are just telling how a file writing of a file happens on name node, and your process might be doing a cron tab, it might be uploading files directly on HDFS. So for each of the file, basically writing of each of those files, this kind of process happens. Mohammed, you have a question. All right, so let me come back to your question. um, a client could also be a command like copy. A client, basically we are saying, is like a machine from where you are basically writing your Java code to write the files or run the files. You can say Hadoop FS put the file on HDFS. So that basically is a Hadoop client which invokes this Java APIs to write the file. So that's, we are saying, is basically a client. It could be a command like copy. Yes, that's correct. And it could be a Java program. It could be basically a Java program, or it could be a shell script which is writing the data to HDFS. So those all basically, the any process basically which basically calls Hadoop file system APIs to write and read data is called as an HDFS client. So Krishna has a question that if a 128 MB file will be split into 264 MB while writing, that's correct. So split is involved. So split, okay, so when you say splitting of a file, that's correct. The file is split into 2 blocks. But when we talk in Hadoop, when we say splits in Hadoop, it means basically in relation to a job. So in jobs, all the blocks that are present for an input directory or input files, whatever blocks are present in those input files, those blocks, they become input splits of a job. So that's basically just the terminology. So Krishna, you are right that a 128 MB file would be split into 2 blocks, and those 2 blocks will be replicated into the 9 times the replication factor. So split happens, yes, but a real split in terms of Hadoop is used in a job running perspective where you say that the data is the input data is split into those blocks, and those blocks are called the input splits for a job. So it's just a terminology. Yeah, so you are also right. So Praveen is saying, what is the criteria for identifying the data nodes by the name node? So that's the name node algorithm. So it basically looks at the disk space available, and so if data node has say 5 drives, so it will see in round robin fashion that which of those drives have space available, and it will basically tell the client to use that data node. So it's in a round robin fashion. So Praveen has, what is the criteria for name? Praveen has a question. What is the criteria for identifying the data nodes by the name node for a file? So which we just discussed. So Mohammed saying is, what is the maximum block size that could be configured? So Mohammed, we just had this question yesterday also. So maximum block size depends on the so the block size is defined as an integer on Hadoop system. So maximum block size could be based on integer limit is 2 GB, but mostly you will see nobody would do a 2 GB block size because it's basically waste the files, because when your files go to Hadoop system, every file would not be a 2 GB file. So you'll basically be wasting your space on HDFS. So that's why people go by 64 or 128 MB. So name node, Mohammed saying name node tells client APIs. Sorry about that. So name node tells client IP of data node or host name. So basically name node will tell IP or so it basically depends on it is. So mostly you will see that people, when they basically configure their Hadoop cluster, they set up a DNS, or they will basically have the host name configured. So it can tell IP or host name. So mostly it would be IP. So Narayan is saying, is there a console where we can see what are the allocated occupied space memory on each node? Right. So once we do our cluster setup today, we are going to look at that console also. So Muhammad is saying, how do client know name node identification of data node? So client does not need to know name node identification, because client just wants to write data, right? So it just needs space where it wants to write the data. So name node will identify the space where the blocks and the data nodes, basically where those should go, and it will just tell those blocks to the client, and client will just directly contact those data nodes and write the blocks. So basically a client does not need to know how name node has identified the data node. It will just gets the list of data nodes, and it will just write those blocks to those data nodes. So one was saying, how can name node calculate the size of a file? So based on your block size. So if your file size is say 128 MB, your block size is 64 MB, right? So name node will basically look at the file that is coming, and it will basically divide it by the block size, and then calculate the number of blocks, and then decide which block should go on which data nodes. Okay, so Shripal is saying, where does DFS run? Is that the one on the client machine? So basically, Shripal, as I just discussed, that distributed file system is all the nodes in your cluster. So all these 3 nodes that you are saying, so these 3 nodes basically make distributed file system. This big box basically means these data nodes, these 3 data nodes plus all the other data nodes that are present in your system. They all basically combine together and they form the distributed file system. And Jagdish saying, who will create the files? It is Hadoop admin's responsibility. So Jagadish is saying, who is going to create files? It is Hadoop admin responsibility. It could be anybody who is creating the files. As you might have 10 people who are basically 10 different teams who are writing data to Hadoop. So those teams are basically writing the files, and they could be just some users, or it could be Hadoop admin also. If those users don't know and they want Hadoop admin to basically upload data to HDFS every hour or every few hours, then it would be Hadoop admin. So it would be some users basically who would be writing the files, or it could be an automated process that runs every hour and gets data from somewhere and writes it to HDFS. So Sanjay is saying, if my file is 65 MB and contains one record, is it going to be split into 2 blocks? No. So if your so if your block size is 64 MB and your file is 65 MB, then yes, it will be split into 2 blocks, because block size is 64 MB and your file is 65. So 1 MB is still left, and name node cannot basically just leave that 1 MB. So that 1 MB goes in another 64 MB block. So basically you are wasting the space in that block, but that's how it is. So that's why we say that on Hadoop, you should not write a lot of small files, because your block size is big, 64 MB. If your file is say 1 MB, then the space of 63 MB is just wasted. So Shama is saying, is the DFS creating blocks? So DFS is not creating blocks, right? So HDFS client is basically telling the data node to create blocks. So HDFS client will send the information, the block information, and data node will be the process which is going to store that block on its local disk system. So data nodes are basically storing the blocks, and HDFS client will just tell that, okay, I want to write this file. So data node will basically write the block that it is supposed to write and store it in its local files, local storage. So data node will basically write the blocks. So Shiva, is what is the response from the name node after 2? So after 2, basically name node tells the client that these are the list of blocks. These are a list of data nodes that you should contact for each block. So then the client at number 3 will start writing to the file system for each of the blocks available. So number 3 basically signifies the writing of the blocks to the data nodes, and the write would be a pipeline node, pipeline write, as explained in this diagram underneath with the 3 green data nodes. So Shripa is saying unique file system is part of OS code base. So where is the code binaries for HDF for DFS? So basically, that's again something once we do installation, I think it will be more clear. When we install Hadoop, every node will basically have a directory where Hadoop binaries are installed. And when they are started, they are provided a class path of those binaries. And that's where they will basically going to read all the jars. A data node will know, data node daemon will know where its libraries are, name node will know where its libraries are, task tracker will know where its libraries are. So once we start today, I'll show you. So if I forget, please remind me. So Shama is saying, what if the record is more than 64 MB? So I think I already covered that part question as Sanjay's question, that if it's 65 MB, it will be split into 2 blocks. Yes, so Shama also is saying the same thing. So Sanjay is saying, in my example of split blocks for a single record, does the map step does the block chaining? So again, Sanjay, we are not talking about maps or reducers right now. Right now, we're just talking about writing the data. So right now, the only components that are in the picture are name node and a data node. So map step will happen when now you are just writing the data. When you actually start running a job which reads this data, that's when the map step will come. And then the job tracker will basically contact name node. And again, name node will know that when I wrote this file, it was on these data nodes. And then it will tell this information to job tracker, and then job tracker will start the task tracker, the task which is a mapper or reducer on these data nodes, and that's when they will read this data. So Fani is saying, in this process, does data node contact name node directly stating they completing the data right? Yes. So data node periodically send their block report to name node. So they will basically also tell the name node that my block is complete. So Fani is saying, if she has a 200 MB file, it splits into 64 plus 64 plus 64 plus 8, right? That means 4 blocks. In case 4 blocks is wasted for rest of 56 MB, yes. So if your file is not aligning on the block boundary, then you are going to basically waste the blocks. Yes. Okay, so hopefully the right is a bit clear. So we had a lot of Q&A on this, I guess, so it should be clear to everybody. So let's go to our next slide, which again just tells the same thing, that what is a pipeline right? That you are basically the name client, the HDFS client is basically asking name node to add the blocks, and then it gets the block location back and it starts to write, and write happens as a pipeline where data node will basically get the block and it will start writing it, and then and it's also tell the next data node, and that data node will start writing the block and it will tell the next data node, and then once they are done, they will just send their block information back to name node, and once all these 3 data nodes are done, this data pipeline is done, they will send the act back to the HDFS client. So Fanny is saying that lost my previous question. What was your answer? Does data node contact directly the name node? Does data node contact the name node? So Fani, what was the question? So it's in this process, does data node contact the name node? Right. So that's what I just explained, that once data node is done, they are going to basically periodically send their block report. So when they send that block report, then name node will also get the new blocks that came to the data node. And they also basically in this process also, they are basically going to tell name node that we got new blocks. So Sumati Singh, is there an integrity check? So yeah, that's as a part of write, basically those APIs, they do all those checks, right? How so Shreepal is saying, how is failover handled in a pipeline write sequence? So if a failover happens in this case, then this basically the failover, if the data node, say for example, fails, then client is basically going to get a response back that the process is not able to write, and that write will fail. So in that case, client will have to basically contact name node again to get the new list of data nodes. So for example, if it was writing the first data node and this data node went down, so then the process cannot be finished. So this client will basically get an error response back that could not contact data node or not able to connect to that data node. So in that case, the write will fail because it was not able to contact the data node, and then it will basically have to contact name node again to get a new list of data nodes where it can write. All right, so hopefully pipeline write is available. So this is again another explanation of this replication. So what we are saying is that name node is going to basically store metadata, which means every file's blocks it will decide, and it knows the overall file directory structure, and it knows where the data block is placed. So if say this user Doug info file, there was a file and it had blocks 1, 3, and 5. So and replication factor is 3. So one block is replicated on this data node, and this data node. So basically there are 3 copies. Similarly for 3, there are 3 copies. So based on replication factor, there will be 3 copies done for each basically block. And then we have a concept of rack awareness. So there's another question by Shripal before that. What would happen to previous write blocks? So let's go back to this thing. So for example, data node failed in the second say state where second write. So in that case, because this is a pipeline, so when this fails, this data node tells back to this data node that I have failed. So this big data node will just relay that message back to the client and say that we could not complete this write because this data node failed. And then this data node's basically write call has failed, and it will have to basically handle that failure by either rewriting the file or somehow it has to basically rerun that process. So it all now depends on the client whether it want to rerun or not rerun. But if a data node has failed, then that write basically will fail. So Mohit, what are the different replication factors, and explain explanation 1 and 2, and do we have 4 also? Okay, so let's go back to our replication screen. So replication factor, as I explained yesterday also and today, that by default it is 3. So if you are, so for example, user Doug info has block 1, 3, and 5. So it has 3 blocks. So block 1 will be present on 3 data nodes at any point of times, which is data node 2 in our case, data node 3, and data node 4. And block 3 is available on data node 1, data node 3, and data node 4. So you can see that every block is basically copied 3 times based on the replication factor. If your replication factor is 1, then it will be just on one data node, nowhere else. So that's how basically replication happens, that all the blocks a file is comprised of, name node will make 3 copies of each block. If this hinfo had 1, 3, and 5, there will be 3 copies of each of these blocks. That's all replication means. So Mohammed is saying, what are the different replication factors play in replication 1 and 2? And do we have 4 also? Mohammed, I could not understand the question. So Mohammed question is, what are different replication factors? So Mohammed, replication factor is something that you configure. By default, it is 3. You can make it 1, 2, 3, 4, 5, 6 based on what you think is a good configuration for your cluster. But most companies leave it 3 because 3 is a good factor, because beyond 3, then you are going to make 4 copies of the data, and then your cluster capacity basically decreases because you are now saving more data for just same file. So that's why replication factor is usually kept as 3 in most production systems. You can make it 1 or 2 or 4 also based on the space that you have in your cluster. Okay. So Fun is saying you're going to walk us through important configuration files in this session to do all these configuration, correct? Yes. So that's the next thing. So once we are done with this, we need to start on that. So I think in next 5 minutes we need to finish this thing, and then we need to get started on our cluster setup. So yeah, so funny, that's correct. So we are going to do that configuration setup as I gave in my agenda. Also, we are going to go through all of that. But before that, you need to understand how things are, because if you don't know what a data node is, what blocks it store, if I give a demo, you won't be able to understand what I'm talking about. So that's why you need to understand these slides before we proceed further. Okay, so we need to discuss briefly replication and rack awareness. So replication, as we already discussed, based on how you would configure your cluster, you will have the replication of the blocks. If your replication factor is 3, your block will be replicated 3 times. If it is 2, it will be 2 times. And then we have racks awareness. So what we mean by racks is like, you can think of like a rack in a library. You have a book rack and you have books in that rack. So similarly, in production environments, all the nodes basically are in a rack. A rack will have a set of nodes. For example, in our case, rack 1 has 4 nodes, rack 2 has 4 nodes, rack 3 has 4 nodes. So if you have basically rack awareness setup, so that's again a configuration setting that you make your Hadoop cluster rack aware, which we will cover again in our third or fourth module. So once you do that, then Hadoop knows that I have multiple racks in my system and I need to place my nodes on based on the racks that I have available. So what happens in that case is the algorithm is that whenever a block comes in, it has to make 3 copies and rack awareness is enabled. The name node will make 1 copy on one rack and the 2 other copies will go on another rack. So similarly for block B, you see the blue one. So first copy is on rack 2 and the rest of the 2 copies are on rack 3. For block C, which is green, first copy is on rack 3 and rest of the 2 copies are on rack 1. So that's the algorithm that name node does is first copy stays on one rack and rest of the copies stays on the other rack. So the whole purpose of doing is that in case say rack 1 goes down, then you still have the blocks 1 on rack 2 and block 2 and 3 on rack 3. So that's the purpose of having rack awareness. Say, so if your say rack complete rack goes down, you should still be able to have data availability and the basically blocks are present on other racks that it can be read from. So that's the concept of rack awareness. So basically the whole purpose of rack awareness is the name node is going to make sure that it writes one block on one rack and rest of the 2 copies on a different rack. And that's how basically it makes the rack awareness. And this is the basically fault tolerance feature of Hadoop. So if you don't have rack awareness, what could happen is that name node is not going to look at any racks. So what could happen is it might place all the copies of block A on this rack 1. And if say rack 1 goes down, then you don't have any copy of this block A and all the reads up to the files containing this block A will fail. So that's how rack awareness is important in a cluster, because if you don't make a cluster rack aware, then name node does not use this algorithm of making copies on different racks. It might write all the copies on just same rack on all these say data node 1, 2, and 3 on this rack. And then the rack goes down, then you don't have any copy and you'll have basically data unavailability. So Ryan is saying, how do we get around switch wiring across racks? Is that configurable? So that would be your network configuration, right? So when you define rack awareness in Hadoop, it's basically just a logical concept that you are telling Hadoop that these data nodes are in rack 1. So you will basically talk to your network administrator and find out that what rack has what host. So you will know that our first 4 hosts are in rack 1. So you will just configure a file in Hadoop where you will say that data node 1 is on rack 1, data node 2 is on rack 1, data node 3 is on rack 4. So when Hadoop wants to write, it will basically look at this file and then it will say that, okay, data node 1 is on rack 1. So when I'm trying to write a block to data node 1, then I'm not going to write rest 2 copies on rack 1. It is going to choose another rack 2 or rack 3 and write rest 2 copies there. And switch wiring, so basically every rack will have a switch, right? So when this rack 1 copy is done, then this data node will contact rest of the 2 blocks here, so that will go through this switch and it will basically then contact these two data nodes, and these two data nodes will then write the other two copies of the block. So that is the rack awareness algorithm. So, okay. So now let's go and look at a file read. So basically file read again is basically in a similar way. So again, it won't involve any task tracker or job tracker. Again, we'll have an HDFS client. We have a distributed file system, which is made up by our data nodes. And then we have name nodes. So again, the client will basically make a call to basically read the file, and it will name node will send the block locations, and then it will directly go to those data nodes and read the blocks, and this read will happen in parallel because these are independent reads, so it will read all the blocks in parallel. So Shyama has a question: what is the wait time for recopy the block when one rack goes down? What happens when rack comes back while rebuilding? Right, so that's a good question. So what Shyama is saying that suppose your whole rack went down, so what would happen is in that case name node will basically not get a I would say a heartbeat from those data nodes in that rack, and then it will make those data nodes blocks to be basically unavailable, and it will say that those blocks are under replicated because they were part of a file and they were part of a replication of a file. So if say one data node go down, it had blocks from a file, so it had say one block and two blocks are available, so now one block is under replicated. Similarly, it will look at all the files and find out which are the block copies which are missing. It will make a basically a count of under replicated blocks, and in background name node will start re-replicating them to the exist all the other racks. So if a rack goes down and name node still has copy of the blocks which were present on the data nodes on that rack, it will start basically re-replicating them. And then what happens if the rack comes while it was rebuilding, then name node will basically, then those data nodes will initiate, then they will come back up and they will send their block report to name node, and then name node find out that okay, these blocks are now available, so it will stop basically re-replicating them. And then in that case it might have over replication because it might have already replicated a block and then that data node came back up, so now it might have say 4 copies. So now name node will in the background start deleting the extra copy. So basically name node takes care of under replication of blocks, over replication of blocks in the background. And so that's why name node basically is a memory intensive process. It's going to take care of all these scenario of blocks handling of the file system. So hopefully that answers your question, Shama. All right, so now let's go to, so this was a file read. So now let's quickly answer some Annie's question, and then we are going to go to our Hadoop installation. So I'm saying in HDFS, blocks of a file are written in parallel. However, the replication of the blocks is done sequentially. So can people answer, is it true or false? True. Right. So that's true. Everybody, I guess, is correct because we already discussed that. The blocks written are in parallel, and but the block replication in a particular block happens sequentially. So another question is, a 400 MB file is being copied to HDFS and the system has finished copying 250 MB. What happens if a client tries to access the file? It can basically read up to the blocks which are successfully written. It can read up to the last bit successfully written, or will throw an exception, or it cannot see the file until it's finished copying. So guesses, people? So A, B, C, through an exception. People are saying through an exception. So basically in this case, the answer is A. It can read up to the block that's successfully written, because as we said, when the blocks are being written, the blocks are written in parallel. So if say 250 MB of file is written, then the client can basically read those blocks. It might not be able to read the blocks which are getting written. So the answer in this case is A. Okay, so now let's look at these cluster modes. So now we are going to start basically installing Hadoop. So when we say Hadoop cluster, it can run in basically 3 modes. So first is standalone mode, which is local mode. There's pseudo distributed mode, and then there's a fully distributed mode. So before that, let me quickly check if somebody has any more questions. there's one question by Varun that what happens if the job fails after 250 MB load? So again, I will try to correct Varun that we are not talking about jobs right now. We are talking about writing a data or reading a data. So if we're saying is what happens if the job fails after 250 MB load? So what we are saying is if you have a 400 MB file and 250 MB is written, so in case somebody tries to query that 250 MB data, would he be able to read those blocks or not? So we are saying that it would be able to read the block. But say after 250 MB, it was copying say 350th MB of this was copying like 300 to 350 MB of data, and during that write process fail. So in that case, the whole process will fail. So the whole 400 MB write will fail, and the client will basically get a failure code and it will basically have to rewrite that file. So in that case, you won't be able to see that file if the writing part fails in between. But what we are saying is if writing is happening and out of 400 250 has been successfully written, are you able to query that or not was the question. So you would be able to query that 250 MB, but and that time the rest of the data is still being copied. But if that copy job, basically the copy, I would not say job, copy task fails in between, then that 250 MB data will also be gone, because writes on Hadoop are either full or none. So you write the entire data or you don't write the data. So when you say Hadoop FS put, so if that put fails on certain blocks, then your complete put command will fail. You won't be able to put that file on HDFS. So hopefully that answers your question, Varun. So Fanny is asking, what is popular out of these? Right. So we are going to discuss each of these. So basically, the local mode is when basically you don't run any daemon on the system. It is just for like development and testing kind of mode. You don't have any distributed file system. You just install basic Hadoop and then you just do some development. You have some jar files that you want to run. So that's used only for development process. And then pseudo distributed mode means you are going to run all the basically daemons in a Hadoop system on just one machine. And fully distributed is when you have cluster of machines and every machine runs one daemon. So in production, everybody mostly will have, not mostly, 100% everybody would install a fully distributed mode, because that's how we say that a name node will be a one machine, data node would be one machine, job tracker would be one machine, and task trackers would be on data nodes. In smaller clusters, name node and job tracker might run on same host. But if you have a big cluster, these all name nodes, job trackers, secondary name node, these will be separate machines, and your data nodes and task trackers will be on other set of machines, which are the slave nodes. So funny thing, I have a video 400 MB. When someone try to read, can they see the video still while only 250 of MB? So we were talking in terms of like blocks. So when you are trying to basically use it through the APIs, when you have written and you are trying to read those through the API, so you would be able to read the blocks which have already been written on HDFS, because those blocks were already, the rights of those blocks are already complete and they are already available. So Varun is saying another question is, a commit has to be done in order to see the complete data, right? So the commit, yes, the commit would be when for the blocks, for when you are trying to basically write the block. So you have multiple set of blocks, right? So those block written is being happen in parallel. So once all the blocks are written, then basically the client will get the final commit code that your file is now written on HDFS. All right, so now let's start with our installation. So what we are going to do is we are going to use a virtualization environment. So I don't know if you guys were able to log into our LMS. So what I have, for example, is something like a Oracle Virtual Box Manager. So where basically you can create multiple virtual machines. So what we do is we basically create, basically first of all set up virtualization software like a virtual manager. This is for Mac, and then you also have like VMware players on for Windows and PCs, so you can use that. So first thing is to get VirtualBox Manager. So what I did was I just went to internet, I downloaded VirtualBox Manager and installed it, and when I installed it, it opened up this session, and it basically tells me I can create a new virtual machine and I can look at those settings. So what I did was I created all these virtual machines. So let's see how basically we create this virtual machine. So So before that, Sanjay has a question. In case of a failure after 250 MB or 400 MB block MB file, is 250 MB written rolled back and write process starts again? Yes. So that's what I said, that when you write data to HDFS, your data would be either full or it would be none. So the question was more about like, if you are writing and within the write process is still going on and 250 MB is written, so can you read that data or not? So you can read that. But say your writing process failed, then 250 MB is also part of your complete write process, which is 400 MB file, right? So in that case, the whole file will just go away and you won't see anything because the process has failed. If the process would have completed, then you would have been able to see the whole 400 MB file. So in that case, client will basically get a failure code and it will have to basically rewrite and get the new blocks from name node and write the file again. So Ryan is saying you have VirtualBox, so that's good. So Ryan is saying, do we have any sizing recommendation for distributing services while configuring cluster in prod? Yes. So Narayan, that's also we are going to discuss in our today's. After we are done with this, we are going to look at the cluster configuration and see what should be the sizing and what are like some general like recommended and used configurations for sizing in production. So Ashok, hi Ashok. So Ashok, do you have a question? Can you explain pseudo system? Right. So Ashok, we are going to go, as now we have started the installation, right? So this is what going to be, we are going to discuss for next half an hour. So this will answer your all those questions. So pseudo system, Ashok is saying, can I explain the pseudo system once again? Right. So I'm actually going to demo this as we go. So we are going to now start the Hadoop installation. So initially we are going to start with the first mode, which is local mode, and then we are going to go with sudo and fully distributed mode. So let's discuss each of these one by one. So standalone, hopefully everybody is clear that we don't run anything. I'll show you how it works. Then sudo distributed means run everything on just one machine. Fully distributed means the real production scenario. That's the way how Hadoop is run, that you have multiple machines. One machine is running one kind of role. So name node is running on one machine, job tracker is running on another machine, your secondary name node is running on another host, and then you have your slave nodes which run data node as well as task tracker. So you'll have basically, say suppose you have 10 machines, so one machine would be name node, one machine would be job tracker, rest 8 would be your data nodes and task trackers. So that's basically means fully distributed machine, the distributed mode. So hopefully Ashok, is this is clear now. So sudo is dev, or it is used in, for example, you are say test doing a POC and you are running something. For example, if I am trying to set up a small Hadoop cluster, I might set up a sudo distributed mode to just test things. So sudo is also kind of a dev. So in production, or when you have to say you have real data and you want to test Hadoop cluster, then you'll usually always have fully distributed mode. All right, so now let's get back to our virtualization environment. So this is how we are going to basically do the Hadoop installation. So everybody would also basically need to have the software VirtualBox, or you can have VMware from Windows. So what you would do is you have to basically, we are going to create one virtual machine for each of the daemon that we run in the system. So what you do is you basically click on new, and then you can basically create a virtual machine. So for example, I'm trying to create a machine. I'll say lab 1, and you give the type of um, um, OS that you want. So because VirtualBox lets you, it's a virtualization environment, so you can basically install any kind of OS. So since Hadoop runs on Linux, so we are going to go with Linux, and then you can have different flavors of Linux. You can have Ubuntu, you can have basically Red Hat, you can have Linux, you can have CentOS. So we are going to go, I'm going to do it with CentOS. So for CentOS, you select basically other Linux and 64-bit. Then you click on continue. It tells you how much memory you want, so you can go with any basically value based on the size of your laptop or your uh, machine. So I have a 16 gig basically RAM, so I can make it 512, or I can make it 1 MB. So you can just increase the number, or you can move this bar left to right. So I'll, for time being, I'll let it stay 512 MB. and then I continue, and then it tells that it is going to create a virtual hard drive. So you can either say no or yes. So basically just keep on creating this, and then it asks you what type of drive you want. So you can see these different options. So usually it's recommended to use VMDK because VMDK is interoperable between the um, which basically VMware player and this. So basically if you go to, for example, you want to move this VM image to a Windows machine. If you have VMDK, it would work, but if you use basic VDI, it won't work. So usually it's advisable to use VMDK. And then it's saying the hard drive, you want to make it fixed size or dynamically. So usually it's good to leave it dynamically because it will just then shrink or basically increase based on the space when it's needed. And then you can give the name of the hard drive, and then you can say what would the maximum size of the hard drive. So it is saying 8 right now, and then you just click create. So you can see that now it has created a new virtual machine for me, which is called lab 1. And since I have not done anything, it was a very quick machine, and so it just created it. So now I can go here and look at the settings. So it will have all the settings that I basically initially created. So you can say that I specified a Linux machine, and I said the Linux is CentOS. And then on the system side, it tells you how much memory you have allocated to it. On the storage side, it tells you how much storage you have. You have said maximum 8 GB. And then on the network side, you can basically tell what kind of network adapter it will have. So you have the options of NAT, bridge adapter, and then you have host only adapter. So NAT means that when you have a VM on NAT, basically you cannot talk to internet because it will be behind a firewall, and it will basically assign a NAT IP to it. And then bridged means that it can basically talk to internet and can talk to your laptop also. And host only means it can only talk to your laptop, it cannot talk to internet again. So mostly it's good to make it bridged so that you can basically get files from your laptop to your virtual machine. So we'll make it bridged. And then we go under storage. So here we can see that the controller, so you have to basically tell what image you are going to use to for making this VM. So if you are making a CentOS, so basically you go to CentOS website and download the image. So I download a minimal image, and there's a DVD image also. So I'll say that, okay, please install this CentOS server on this. So basically I'm now just specifying the parameters that I need for this virtual machine. And once I do this, now I can basically go here, and so I'll say press OK, and then I can start this virtual machine. So when I start this machine, now this is a new machine. It will start installing the CentOS because I just gave my image as CentOS. So you can click on enter and it will start the installation. So you can see that is going to just now start the OS and uh, basically install the file system, and then try to make the host name, and it'll ask you certain questions. Just continue on those questions. It says to begin testing, you can say skip or just start installation. So I'll say skip, and so it will start installation. So it says welcome to CentOS. It will tell me what language do I want. So I select English, and keyboard selection I say US. So I'll just go by default, and it's saying that it asking me to reinitialize everything. So I'll just press my arrow key and go to reinitialize, click enter, and time zone I'll leave it as it is, press OK, tab to move to OK button, and then press enter. And then it's asking me passwords, so I'll enter a password for this machine. So make sure you remember this password, click OK. And then it is asking that it's going to replace everything existing on this machine because it is a new VM. So I can just say yes. So I'll just press tab and go to OK button. And then it is saying that it's going to write this changes to disk. So I again say enter on this, and now you can see it has started creating the file system. and starts basically installing the OS. So this is how basically you will start do a OS installation. So this process is going to take some time. So what we did was I did these steps, and now I already have a basic CentOS virtual machine up. So Ryan is saying, can you go back to the disk image step? Disk image step, if you meant this question. Where do I find CentOS install you just did? So basically, if you look under controller, this is where you go to, you specify the CD or DVD drive where your OS is. So when I started my installation, I clicked on this. So I basically have already installed. So when you have your OS installed, you it will basically, now it is finding it out from my previous basically it's remembering it. So what I did was, you if you don't have, so what will happen initially is you will click on this and you will only see choose this option. You won't see rest of these are seeing there because I have installed these images previously and it see them in the history. So you will click on this and you will choose, find the location where you downloaded your image, and you just click on that and then press, it will, you press open, and then you will see it in this list. And once you do that, it will be assigned to this controller, and that's the image it will use when you start this VM here. So where you think I downloaded full version, that's fine. It basically, if you have enough hard disk space, so that's, you can download the full version also. I go with minimal because I don't really need full version, because my, like, I'm just running basic system, so it's able to, and the minimal is able to handle. And if I need something else, I just download that particular package. So, and funny thing, are you sorry, are you going to have three nodes like name node, job tracker, data node? Yes, funny. So right now we are doing one installation, so we're going to go through each of these steps. So yes, I'm going to show you the pseudo distributed mode as well as full distributed also. So let's see. So funny thing, I see you already have them in your VM, right? Because this process takes time, so that's why I wanted to show everyone how to create a VM and how to start it, and then basically we can proceed. So now basically it says that your CentOS installation is done, and you can basically reboot it, and then your machine will come up. So now your machine is ready. So that's how basically you will basically create this. And then what you can do is you can basically either clone this machine. So you can even clone this machine. So once I turn this off, I would be able to clone it, or you can just repeat the same steps and just create multiple virtual machines. And because whenever you create it initially, they will all be powered off. So they are not going to use your memory. Only when you have them running, they will basically be using the basically your memory, so your host system's memory. So then you basically enter the password that you selected, and then it will bring you to the prompt. So this is how basically you have a basically set up a minimum virtual machine, and you have, like, this is like a host now, like a Linux host, where you can install your name node, you can install your job tracker, or you can install your data node. So right. So while you're saying where to find CentOS minimal install, so you can basically just go basically on internet, and you can see, you can say, for example, here you can say CentOS minimal install. So you can see that you can go to mirrors, and based on the place where you have, you can select on one of the mirrors, and when you click on that, these mirrors, you will see there is minimal, there is complete, and there's live DVD. So live DVD sometimes does not work, so I'll suggest use minimal, or you can use this bin DVD. So based on, so you can see that the full DVD is 4.2, but minimal is just 398 MB. So I just went with the minimal because that serves my purpose. So that's how I basically now have a basic host up with a OS system. So Fani is saying, what is OS recommended for name node? job tracker, and data nodes. So funny that again depends on organization to organization. So mostly it can be in any flavor of Unix. Red Hat is most recommended then, but people use CentOS also because it is open source and it does not require any support. And a lot of, you will see that all the technology companies, they use CentOS and Ubuntu, but all the companies like finance companies where they want uptime all the time, they have Red Hat say contract, they will go with Red Hat. So it would depend on company to company. So you'll see that a lot of people, it's a mix of Red Hat, CentOS, and Ubuntu. So funny thing, can I use Fedora for all? Sure, you can use Fedora also. And so funny saying, can I use CentOS for name node, Fedora for rest of the nodes? Usually people don't do this kind of OS mix match. So basically mixing. So if you are setting a Hadoop cluster, it is usually suggested to have same OS for all the components in a Hadoop cluster. So I would suggest go with just one OS, but you can try it. If it works, it's great. All right, so now basically we have our basic VM up, and now we'll do few things. So first of all, what we need to do is we need to make sure that we have a host name and we have it configured. So what I can do is on this machine, I can do like host name and give a host name to it. So for example, I can say lab1.cluster1.com. And then when I run hostname command, it will have that name. But if I go out and come back again, this hostname won't be saved. So this hostname is just for this particular session. So to save this, what we do is we go to etc sysconfig and under network. So, so when you open this file, basically you write your host name here. So I'll say my name as lab1.cluster1.com. So now when this machine reboots, it will still have this host name. So that's the first thing that you should do to save the persistent host name. And once you do that, then it's good to modify your etc host file. And basically you, instead of localhost, you basically just say the name that you have for this host. And then we'll also see how to assign an IP. So let's first assign the IP to this machine. So on Unix, basically you run if config -a, it tells you whether you have any IP or not. So right now we haven't configured any interface for this. So right now it's just a loopback, which is 127.0.0.1. So what I'll do is I'll now assign an IP for this. So for that, what you have to do is you have to go to etc sysconfig, and then you have network scripts. So you go under network scripts, sorry, network scripts, and then here you'll have like all the scripts for interface. So let's go with our basic interface, which is eth0, and there we'll say that on boot we'll make it yes, that whatever IP is assigned to this machine, what we are saying is on boot, just use, basically store that IP and it, so that it won't change that IP. So once we do this, now we will basically just do a reboot of this machine. So what I'll do is if I cross, it will tell me whether I want to save the machine state, I want to power it off. So I'll say power off, and then I will just start it again. So it is booting up. So it's asking me the username. So I'll say root and the password that I entered for this machine. And now when I do if config -a, it has assigned an IP. So you can see that under eth0, the INET address is 10.0.0.23. So that's the IP that has been assigned to the machine. So now we have an IP for this machine, and now we have a host name. So what we will do is now go under etc host file and update this IP. Let's say 10.0.0.23, and we'll give the name, host name, which is cluster1.com. So that means if some any other node, for example, this is a data node and name node refers to basically this name node, this data node, then this data node's its host will basically be able to resolve it. So that's why we need to add the IP here. So you save it. So this is one way, plus most in production people do like a DNS. You have a name server and you basically do the resolution from there. So that's also something that you guys can try in your setup. So this way basically now we have a machine where we have a host name, and when we have a IP assigned to it. So now we can actually go and start the installation. So basically this is my similar machine. And now because I set it up as a bridge adapter, so now as you can see, the typing in this shell is really difficult. So what I do is once I have an IP assigned, for example, in this case, I had 10.0.0.23. So now I can go to my terminal, and what I can say is basically open a new tab and say SSH. Let me basically increase the font so that everybody can see. So now I can say SSH root at 10.0.0.23, and now I have like my terminal, which is much easier to type, and it's a better interface than this guy. So now I can just do it everything here. So this is basically the this is how why you will do it, because we set a bridge adapter. That means this VM can now talk to my host. So when in my host machine from my Mac terminal I open a terminal, I can just give the IP of my VM and just log in, and then it would take me to the VM. So now I have entered in my VM. So that's how basically you can go from your host system. So Mohammed is saying, I can do this in bare metal Linux also. Yes, you can do it. So as you don't have a Windows box, yes. So like my Mac, so I'm also using Mac, right? So I don't have Windows, so I'm doing it on Mac, and I'm just getting a Linux. Uh, so Mohammed, if your question is that you have a Linux OS already set up and you just want to use that on directly on a Linux machine, yes, you can do it. Basically, what we have done at this point is just set up a Linux machine on our laptops. So in Windows, we'll use something like a VMware and do the same things, or a VirtualBox. VirtualBox comes both for Mac as well as Windows, so that's why we are going with VirtualBox. So at this point of time, we have set up a Linux machine, which is basically now our machine to install Hadoop. So now we will start with the installation of Hadoop. So now I'll go to my this name node, and so this was basically just to show you how to set it up. And now I'm going to go to a machine that I've already set up so that we don't spend time in doing this. So I will again go to my NN1, see where it is, and so you can see it's like really difficult to see anything here or type anything. So that's why your Linux terminal is basically much easier to work with. So that's why I set a bridge adapter so that I can just type everything easily here. So I'll again go to my machine 10.0.0.13, type the password, and this machine I have named NN1. So same way that I just showed you how to name and have the machine's host name. So the host name is this, and I have the IP defined in itsy host. So right now you can just look at this one. We'll discuss about these later on. So right now I have one machine where I have set up my IP, and I have configured my file itsy sysconfig sysconfig network scripts. So basically, as you can see that I'm typing something, and if I don't find a file, it gives me a list, right? So if I'm typing something and I press tab button, it will tell me all the files that start with I. So after pressing I press a tab and I see all the files available because I don't remember the name of the file. So then I can look at the list and I need this first one. So I'll say ifcfg dash eth0. So that's like autocomplete feature that now when I press tab, Unix will with this or shell will automatically find the file with this name and give and auto complete it. So this is what we did, right? So on boot, we said yes, that whenever this machine gets rebooted, we are saying that use basically get the same IP from DSCP for this machine, so that when we don't have to redo these steps of changing our IPs are in our etc host file. So now this IP 10.0.0 basically 10.0.0.13 is set up for this machine, and I made this the host name nn1, which I'm saying that no name node, and I've used a domain called cluster1. So that's for my testing. So now I have this machine set up, and I have set up the host name for it. So Shamis, don't you give a static IP 10.0.23 seems to be DSCP. Yes, so you can have a static IP also, or you can just use this way of doing it under network scripts under etc config, where you say that on boot basically just use this IP. So Mohammed is saying this is name node, right? So right now this is nothing. We are just saying that we have one machine where we have a CentOS machine, and now we are basically going to install Hadoop on this. So Sanjay is saying from my Windows machine, what do I need to do to SSH from Windows to Linux host? So basically, yeah. So with Mac, it comes with this app called Terminal, and Windows has something called Putty. It's called PUTTY. So you download Putty, and then you just type the host name, and you just SSH to that host on port 22. So that would be Putty. So Muhammad is saying name NN1 is name node. Yeah, Muhammad. So NN1 is the name I have used for this machine, and I'm going to make this machine name node. So I called it NN1. Yes. Right. So first thing for Hadoop, what you need is basically have Java. So for Hadoop, you need Java 1.6 and higher. So first, so what you have to do is you have to go like you install CentOS. You have to basically you have to download Java. So again, you look at that, and then basically you go to Java website and you get the download Java. And what I do is whenever I have to download, I basically go to something like index of Java, and so index of, I'll say Java 1.7. So it will basically take me to, basically I'm trying to find out a place where I can have an IP of basically a location where I can just directly download the Java. So I can even say JDK, and so basically you basically get the download. So you have to download Java 1.6 and higher. So in my case, I already downloaded it on under my directory. So I got JDK this RPM. So what you do is you can either download it to your host machine and then SCP to this machine, or you can just do something like a wget. So let me try to show you how to do a wget. So what I'm trying to do is find this RPM. So you can go to archives, and this is not right. So this index, right? So what I do is I go here. So this is basically a location where I have this Java. So what I do is I'll say wget, copy this complete path, and I copy the RPM for Java at the end of the path. So basically copy it at this end of the path and do a wget on this complete path. So maybe what we can do is do this thing on this lab one, which is a new machine. So what I can do is go under OPT, do a wget on this. So now since this was a minimal CentOS, so my command might fail with wget not found. So what I'll do is I'll do yum install wget. So whatever thing you need, you can basically install. So you'll see that it will start getting it from, start downloading it. So to download these packages, you need to have wget. So you can just say yes, and wget will be installed. Now you can just type wget on this complete URL, and you will see that it will start downloading this RPM. So that's one way of basically not going to your Mac machine and then try to get it on this machine. So you can just run directly wget on this command line, and it will start copying it. So since this is going to take some time, so I already downloaded this RPM here. So next we are going to do is we are going to try to install this Java. So that's the first step you need to have on the system, that Java should be installed. So what I'll do is I'll run something like rpm-ivh. So that's the way to install an RPM. So I'll say, so you can see that it will basically, so I already installed it, so it will say it's already installed, otherwise it will install. And now if I run Java, it will basically have Java in the path. I mean, it won't have in the path, but then you have to basically, now you have Java in your system. So you can basically now say, go under user Java and the version that you installed, and you can go under bin and you can run commands like JPS. This JPS is a command that tells you about Java processes. So, Ashok is saying, do I need to have Linux OS to do this? So, Ashok, we tried on CentOS, right? So, CentOS is a flavor of Linux, which is, so we are using CentOS. So, you can use same thing that I'm using. You can use Ubuntu, or you can use Red Hat also. So, Ryan says, can you paste the download link into the chat window? Yes. So, this is the link. So, let me see if I can paste it in the chat window. So, let me know if everybody saw this chat download link. But then this could be like any JVM, right? So I'm going with Java 1.7, so you can try this. And Sanjay saying, are these instructions in LMS also? Yes, they're also in LMS. So you can follow them from there also. Great. So now we have Java, and now what we're going to do is that we are going to basically set up our, so now we have to decide on a user that we want to run Hadoop as. So it could be any user, it could be Hadoop user, Hadoop, say your own user ID, it could be John. So we have to make sure that we have basically the user added. So what we'll do is you have to run a Unix command called user add to run. So before that, what if I do ID? So ID is basically identity. So if I do ID, it tells me what ID I am. So basically right now I am root. So what I'm going to do is I'm going to create another user Hadoop. So in this case, I already have this user. So it basically did not do it. So you can also do like user, let's try this user del Hadoop and try to create it. So now I'm trying to create user Hadoop. So now it is saying that it has create a user Hadoop. So when I do ID Hadoop, I will have a Unix user ID assigned to this user called 502. So that's the user which we are going to use for our Hadoop installation. So I think you may also want to save all these commands in a file. So well, these commands are also available on LMS in documents. So that's why I'm not saving them here, because you can always follow them. And then you will also have my recording. So you can even go through these steps. Um, so these are already present on LMS as a file. So you can refer it from there. So that's the first step. So once you have set this user, so now what you can do is you have to basically set up a password for this user. So you can basically run password Hadoop, and it will basically ask you for the password setup. So I can say type a password, and if it is too simple, it will fail. So so basically you should make sure you have a good password. And now I will basically go to this user sudo su dash Hadoop. So basically what I'm saying is, so actually I don't have to do sudo because I'm already root. Sudo is to basically go as roots, run command as root. So what I'm saying is su dash Hadoop. Su is switch user. So I'm switching user to Hadoop and I'm giving a dash. Basically dash means that please get the profile of this user Hadoop also. So now basically now I'm as user Hadoop. If I type ID, now I'm user Hadoop. So now first thing that I have to do is I have to make sure that I have Java in my path. So Ryan is saying, should we make lab1.cluster.com as our name node? Yes, we can use that also, but you can see that it is still downloading Java. It's going to take some time. So that's why I've already downloaded all these things here. So I'm basically just trying to show the steps because we want to finish the demo within our class frame, and we want to discuss a lot of other things also. So if we wait for this lab one, it's going to take some time. So that's why I'm doing the same things that you would do on a new VM on this machine where I've already just downloaded RPMs, and basically I just need Java RPM and I need Hadoop, basically tar file. So once that's done, then we are just going to go with the configuration. So right now we are working on setting up Java. So you have to make sure that Java is in your path. So as you saw that Java was installed here, right? So what I will do is I will go in my bash profile. So I'll do something like dot bash underscore profile, and there I will set up a Java home, which will point to the directory where I just installed Java. And then I will just say path, that path will be bin for that, and that export that path, so that every time when you go, because right now we just install Java, it's there, but if this path is not added, next time will come, then we type Java, it will fail. So basically let me try to just remove this from here. Right, so initially this looks like this, right? So when I go here, I go as user Hadoop, when I type Java, it is still able to find it from the path. But when I try to say uh, JPS, it would not find, right? All the commands that are present under Java bin directory, they will not be available. So Jagadish is saying you're not audible. Are people not able to hear me? Sanjay saying if it'll help if you open the document with all commands from LMS and have it open side as you are executing them. All right. Okay, so people are able to hear. So Sanjay, okay, let's try to do that. So Sanjay is saying he wants me to open the document and tell us side by side what am I doing. So let's do that. So let's go to edureka.in and go to my courses, and I'm going under, say, installation using CentOS. So I'm going to download this document quickly. I'm going to open this. Right, Hadoop's lab setting. So this is what we are basically following. So Ryan is saying, do we install Hadoop version 1 or 2? Ryan, so yeah, so once I finish Java installation, I'm going to come to Hadoop installation. So yes, so we are going to start with Hadoop 1, and then we're going to discuss Hadoop 2 in our further sessions. So you can see that this is the RPM that we just downloaded, right? So now we have downloaded the RPM for this Java, and now we are basically setting up the Java path. So what I'll do is I will go in my bash profile, and I set up basically a Java home parameter, which points to the directory where I just installed Java, right? And then I'll type my path is equal to include Java home slash bin directory and the existing path. So right now, let's forget about this one. So this is how we basically now we are adding Java path to it, right? So now when we save this file and we type JPS, it will still complain about the same thing because we have changed something in our profile, but we haven't sourced it. So what you have to do is dot bash profile. So this is called sourcing of bash profile. So it will get all the changes that you have done to your bash profile in your environment. And once I do this, now the Java, now my environment, my shell environment knows where Java is, and I type JPS, it will work. And if I type Java commands, they will also work. So this is something that we have to do on all the machines. Now my Java version is the path that I just sent, and it works. So now we have Java set up. So next thing is to basically get Hadoop download. So again, this is 1.0 setup. So again, I'll go to the internet and I'll usually again type index of Hadoop. So it will basically take me to this location where I have all the Hadoop basically directories. So you can see that we have these versions here, and all the older releases are available here. So this will basically have everything here, right? So we have starting from Hadoop 0.10, 14, it goes to 0.19, 20, 23, and goes to Hadoop 1.0. So you can see that naming convention is bit started with 0.10. So everything under 0.3, basically less than Hadoop 0.23 is Hadoop 1, and after 0.23 is Hadoop 2 basically. So we are basically going to choose, say, one of the regions. So if we go with via with our LMS, basically, you can see it is talking about 2025. So we'll go to 2025, and we are going to download this tar.gz. So again, we'll go the same way. We'll do a wget on this. So let's go to my session. So this Java is here. So just so that everybody wants to see how to do it. So what I'll do is I'll type rpm-ivh. That will basically install my Java. I don't want to waste time on Java installation because we need to configure Hadoop. So that's why I didn't show it. So because it's just an RPM command, it will install Java. And then again, we will do something like this, and then it will get the Hadoop version. So again, I have already downloaded Hadoop on my this machine. So you can see that this is under, I'm as root. So I'll exit out and again go as root from Hadoop user. And I have already downloaded this few versions for our test environment. So once you do this wget and this is not getting downloaded, so I just have this downloaded version here. So now again, we'll try to basically install Hadoop. So for that, what we will do is we'll try to extract this tar file. So this is tar zz file, right? This is a tar and a gzip compressed file. So we have to give this option star minus x g uh, sorry, z v f. So x means extract, z means it's a compressed file, v means give verbose output, and f is like I'm giving the file options. And the file that I want to uncompress is Hadoop 020. So basically I'll give the complete path. I'll say root Hadoop 020.205.0tar.gz, and then I can give the directory where I want to basically untar it. So in my case, I want to run everything as Hadoop user, so I'm going to copy this under the home directory of Hadoop user. So once I do this, basically it is now extracting this tar file under the home directory of Hadoop user. So now this is extracted there. So now again, I will go back to my directory and I'm in my home directory. And if I see, I should have this directory here. If I do ls-ltr, let me remove this link for the time being because we want to start fresh. So that is from my previous class. So once you extract, you will have something like Hadoop 020.205.s. So if we do go into this directory, what we will see is we'll have all the Hadoop jar files. We have conf directory. We have basically lib directory. So if I go under lib, I will see libraries, the jar files that Hadoop needs. And then I go under conf, I have the conf files that Hadoop needs. So there was a question, somebody, that how do jar files basically come. So basically now when you have installed Hadoop, so these libraries are the libraries which have the Hadoop libraries, and these are the libraries that are going to be used. So there is a one library for fair scheduler, there are common tools, common CLI. So all these are the basically jar, or basically which are library files which are coming as part of Hadoop installation. And now like we did the Java path, we have to do the same thing for Hadoop also, because if I type Hadoop now, it will say command not find, because my Hadoop is under home Hadoop 020 and then bin directory, and then Hadoop is there. So once I do this, my Hadoop command succeeds. So what I have to do is I have to type this Hadoop home also in the path environment. So now as you can see that this is a version, right? Hadoop 020, and then when you install next version of Hadoop, this will change. So how usually people do is they make a soft link to the current version that they are having. So what I will do is we'll do ns ln -s, which is a soft link, and I'll say make a soft link of to Hadoop 020, and the name of the link is Hadoop. So now if I do ls-ltr, so now I have a soft link which is pointing to my Hadoop current installation that I have. And anytime I install a new version of Hadoop, what I'll do is I'll just remove this link rm Hadoop. So when I say rm Hadoop, it's not going to delete this directly because it is just pointing to it, right? So it will, it's a 18-byte pointer. When I do rm Hadoop, you will see that just this Hadoop link is gone. And when I get the new basically release of Hadoop, I'll download it and then I'll just create the link to that new version of the same Hadoop, because then you don't have to change your system utilities, all the programs that you are there. So you don't have to, when you get a new version of Hadoop, you don't have to change 020 to 21 in all the different programs. You will just say home Hadoop, and that will basically point to the latest version of Hadoop. So now what I can do is, previously I was, for going to Hadoop, I was typing this big command, right? So now I can just say home Hadoop Hadoop bin Hadoop. So now it's easier for me because I don't have to remember that big version numbering that Hadoop has used. And now again, like Java path, I will also add this path in my bash profile. Because I don't want to type this whole thing again. I just want to type Hadoop. And once this whole path is in my environment, then shell will know that when I'm typing Hadoop, it needs to look into my profile and my path variable. And if there's any path where Hadoop is, it will automatically find it from there. And I don't have to type this complete big name. So like I said, Java. So in this path variable, I'll just add another thing for Hadoop. I'll say that in my path in, so just include all the Hadoop binary path also in your path variable, so that when I have to use Hadoop, I don't have to type big name. Now I'll just type Hadoop and it will work. So again, it won't work till the time I don't source this profile. So I have to do a sourcing of this. So once I do this, now I type Hadoop, it will work. I don't have to type this big name. So now basically we have set up the paths, and Hadoop and Java are now available in our path. So Sumati has a question. When you have a chance, can you please show where is yesterday's recording? So the yesterday's recording should be under the LMS for your um, account. So basically, Sumati, you will log in and you go under my courses, and then there'll be LMS, right? So in LMS, if you go under module 1, you will have class 1 recording. So that's where you should have your recording as well as presentation. And this is where I also got this document downloaded right now. So this is where you should have it. All right. So now basically we have our Hadoop setup. So now what we will do is, now we will start configuring Hadoop. So we set the path, we have the bash profile. And now if I go back to my deck, you can see we have something called standalone mode, right? In standalone mode, what we have is what we have right now. We have JVM running, we have Java running, we have a Hadoop installed, and now I do Hadoop. I can basically run Hadoop commands. So I'll say Hadoop fsls. It will just give me the listing of my current directory. If say root, it will run root. So now basically I'm not actually running any Hadoop daemon. I have not started name node. I have not started data node. I have not started job tracker. I'm just installed basic Hadoop. And this mode is called basically standalone mode. In which, in case we are not running anything, you are just basically just installed Hadoop and you are trying to basically use this for development. So in this case, what would happen is some developer or somebody who is making some MapReduce program, they will use this kind of environment to write basically a file and try to basically run Hadoop commands on that. So usually this won't be used by an administrator ever, because there's no basic use of it. It's mostly for like developing some programs or basically trying to test some programs. So because it has no file system, it can only basically just run Hadoop commands, basic Hadoop commands. So now what we are going to do is we are going to do a pseudo distributed mode. So before that, I'll give everybody a 2-minute break. So in case you have any questions, so I think now it's getting interesting. So I want everybody to take a deep breath and get ready for the pseudo distributed mode. So let's give like a 2-minute break. So if you have any questions in the meantime, you can ask me. So Mohammed has a question that he is not able to find JPS. So Mohammed, when you set up the path, basically, so what you would do is under user Java, then you have JDK version, and then you go under bin directory. That's where all the Java utilities are. So you'll see their Java compiler, you will see their Java, and you will also see JPS here. So here, when you type JPS, it will tell all the Java processes that are running in the system right now. So Ashok is saying, can you open MIC? Ashok, I'm not sure what is MIC. So Mohammed, in the meantime, I'll answer Mohammed's question. In my system, where my Java is installed, here is where is my Java installed. Sure. Yeah, so you can have Java installed anywhere as long as you know the path where Java is installed and you can add it to your bash profile in your path variable, you are good. So now name node is up. And what we can do is we can actually also go to the name node web UI. What we can do is 10.0.0.13 colon 50070. So that's a name node web UI port 500. 8020 was the RPC port. So this 8020 is the RPC port which data nodes were going to use to talk to name node, and 50070 is the web server web UI port. So now you can see that now it says it has one file, it has 0 blocks because no data has been written to the cluster, and it has 100 node space. Right now it says 100% use and there are no data nodes. So next step is to now add a data node, right? So now right now we can say that we have no live nodes, we have no dead nodes. Right now we just have a basic name node up. So, and you can also see the heap size. We defined heap size as 512 MB. So it used 494 MB out of it because some uh, memory is also used by Java process coming up. So this is where this is the value is coming from Hadoop env.sh where we defined it. So name node basically used all the values from there. So next would be now to set up a data node. So for setting up data node, we have to basically again look at the HDFS site and add a parameter. So now what we are discussing is a pseudo distributed mode. We started name node and now we are also starting a data node on the same machine. So what I'll do is I'll again go to HDFS site, and now I will add a parameter which tells the location of data directory. So I'll add this property dfs.data.dir, and I'll say /data/dn1. That's the place where I want to store the data. So this is the property for data, and I need to make sure that this directory exists. So I'll do mkdir on this. I'll make sure that it is owned by Hadoop user /data/dn1, and then I'll go back to my user, and now I try to start the data node. So like I did Hadoop dash daemon.sh start. So when I start a data node, I say start data node. When I started name node, I gave name node. When I type this, so again, the ownership issues. So we have to make sure that we have the right ownership. So I'll chown-r/tm. I'll do make sure that I make all the Hadoop things owned by CHR so that we don't have to do this again and again. So once I do this, I will start the data node. So now when I do JPS, we have a data node. And then what I can do is I can go back to web UI. Initially there was no live node. Live node is 0. I'll refresh this. And now we have one data node. And when we have a space also in the clusters, this data node has 4 GB of space. So that 4 GB of space got added to this cluster. So now basically we have a cluster where we have one data node up. So let me see if we have questions. So Sanjay is saying, can you tell the significance of each of these files? So Sanjay, I actually briefly discussed the significance of those files. Let me see. So we discussed file system image, edits, version, and then the other directory that we have is the image directory. So there it just has like the file system image and it's not needed. So that directory is not important. So all the directories are important in Hadoop. Daemons are the ones that says current. So that's the one that we're looking to. So Narayan is saying each time do we need to format? Only once. So hopefully Narayan answered that question. You will only format name node once in the lifetime of the cluster, because if you do a reformatting, you will lose everything on the, all the data will be lost. Because basically that's like reformatting an OS on your Linux machine, right? When you reformat, everything is lost. Same is true for name node. So Sripal, is the question is, at this point, everything on the cluster is running on the same machine. That's correct. Mahdi is saying, while starting Hadoop, why are we getting warning Hadoop replicate? Right. So that's another thing, because this warning is in Hadoop 2. Basically, this variable is deprecated. So they are just giving us a warning that Hadoop underscore home is not used. So we can suppress this warnings also. So I'll show you in next class how to suppress this. So, but since it's a warning, we don't really care, because after we run JPS, we can see that actually the name node and data node, they do come up. So we can ignore these warnings. It's just that this is a deprecated parameter. So maybe it's saying you should not use it. They are still supporting it, but maybe somewhere future down the lane, they might not support Hadoop underscore home, and then your process might fail. So they are just warning us. So Mohammed is saying, could you type that property in here so that we could copy and paste? Sure. So what I'll do is actually, this should be in the LMS also. So let's go back to the document. Sorry, it's in here, right? So we did Hadoop and then the base machine, virtual manager. So I think there was a question by Ashok also. So you can basically see everything here. Whatever I'm doing, you can see all of it here. It also tells you how to set up a DNS server. So there's additional steps here also. So this is a DNS setup, and then you are adding the user, then you are doing the rpm-ivs, then all the steps that we just did, you extracting the file, then you are chown the file, then su to Hadoop, and you start the process. You add Java home to the export as Hadoop home to Hadoop env, then you look at core site. So all these parameters are there, so you will get everything from here. So question by Syed is, heap size do we need to keep on changing as the file increases? So heap size you will define as Hadoop env.sh. So when name node starts, it's going to use that value. So if you change that value, you have to basically restart name node, because name node cannot dynamically pick up the value that you change in Hadoop env.sh. So when name node has started, it already has the heap size of, in this case, 512 MB. So till the time you don't increase in Hadoop env and restart name node, it won't take into effect. All right. So basically everything is here. So I'll just go back to my demo, because I think doing it live is more important. So now we have the data node added. So that's how basically now what I can do is this. Now basically I have HDFS system up. So now if I have to start a task tracker, then I'll now look at my third configuration file, which is mapred site. So what I'll do is I'll go in the conf directory, and then I look at mapred-site.xml. So again, this will be blank. So what I'll do is, for mapred, I will copy. So you have to just specify the job tracker name. So I'll just say job tracker as the same machine. And if you don't say, it will just take the local. So I'll type this here. And then you can also start task tracker. So this is how basically on this machine we have started everything. We started name node, we have started task trackers. So now we can also see starting a job tracker. So now I also have job tracker here, and then I can also do task tracker. So it is starting task tracker. When I do JPS, so now I have everything on this machine, and now this is like my cluster, which is basically a pseudo distributed mode cluster where everything runs on this machine. And now I can basically run Hadoop commands. I do Hadoop fsls on root. I won't see anything. Now temp directory is created. So what I can do is I can try to copy some file. For example, I have this test file. So I can do Hadoop fs -put test on root. So what I'm saying here is I have a file on my Unix file system and I want to copy that to HDFS. So source is this file and I'm trying to copy it in root directory. So once I do this, it comes back and then I do Hadoop fs ls dash. So now apart from just TMP, I will also can see this test file. So this test file is now copied and now this file is there. So if I go back to this here, so I had 0 blocks, right? So now I will refresh this. Now I have 2 blocks. One basically for this TMP and then for this test file. Then I can even run other commands. I can do cat Hadoop fs. So basically Hadoop fs means Hadoop file system and then the command. So when I do Hadoop fs dash ls, I'm doing a file system listing. When I do Hadoop fs dash cat, I'm doing a cat command, which is just like a Unix command. So I'll do this. It will just type whatever is in this file. This is test. So this is how basically you have a pseudo distributed mode. So now when I have to go to fully distributed mode, what I'll do is I'll go back to my virtual box and I'll have to repeat these same steps on different basically virtual machines. So I'll create each of the, like we created NN1, we created lab1, I created DN1, I created DN2. So I created all of these machines separately and I followed exactly same steps. I installed Java, I installed Hadoop, I basically set up the bash profile and then I went to that node. And now if I start this, I did all the steps and now I can basically go here and see that what is the IP on this machine. So it is 10.10.10.14. So if you have a static IP, then you will have like 192 IPs, but in my case, I have 10.10 IPs. So now if I go here, I can do is SSH root at 10.0.0.14. So I'm on this machine. I did exactly same steps. I added user Hadoop. Hadoop is there. So I again do sudo, not sudo, just su to Hadoop. I go as user Hadoop. I go in the home directory, Hadoop, in the conf directory, and I have again same configuration files. I have to make sure I set up Hadoop env.sh. I set up Java home. I set up heap size. I set up Hadoop home. So once that's Hadoop home is done, then I basically go to core site and I make sure I have my uh, name node defined here. So name node was this node NN1, right? Host name for this is NN1 and host name for data node is DN1. And I made sure that in itsy host, I basically added the entries for DN1, data node 1. I have 2 data nodes, 1 job tracker. So I set that up. And then I again go back to configuration files. In core site, I set up my name node. And in HDFS site, I basically set up my data node. So if you look at the difference on HDFS site on name node and basically Hadoop conf HDFS site. So when I was running everything here, I defined data dir also on name node. But when you run in fully distributed mode, you will only define name dir on name node. Sorry. So basically you just define name dir and on data node, you will just define data dir. So in this place, I have not defined name dir because this is a data node. It does not need name dir. And I specify this directory and I started data node there. I'll just do the same thing here. Hadoop daemon.sh start data node. So in this case, my data directory is cd dn1. So I go in that directory. Again, I will see it has created a lot of folders. So I'll go under current and I look at that. I again have this version. I have the blocks here. So when I go under version, I can look at this namespace ID and I can compare it with the namespace ID on the name node. So I'm going to reduce the size so that we can compare. So I'll go to data nn1, which is a name node directory, go under current and cat the version. So you can see that whatever namespace ID I have here, that's the same namespace ID I will have on data node. And because this data node is now talking to this name node. And then in the storage ID, you can see that there's an IP of this machine and the port where it is running. So, and the storage type for this guy is data node. That guy was name node. So now this storage ID is what is being used by name node to identify this data node. So now when this data node comes up, it will basically have these many blocks. It will send this block report to name node, and name node will know that these blocks are on this data node. And if I go back here and I refresh it, I should have two live nodes, right? So if I click on the live nodes, one was the node that I started on name node, and another one was the DN1 that I just started. So this is how basically you set up pseudo distributed mode, that you set up data node on separate machine and start data node there. And similarly to this, I have another machine job tracker one. So I go there and then I start the job tracker. Like name nodes, I have job tracker. So if I look at IP for that, again, set up the same way. So I'll open job tracker machine. So I'll SSH root 10.0.0. This is, I guess, 14. Let's go and see what was that. So job tracker, and click on show. It will show me the virtual machine and 16. So I'll go to 16. So here also again, I'll first of all add the user. I've done those steps because I don't want to spend time on doing the same things again on every host. So you set up Hadoop. Again, you have your Hadoop version downloaded, and under conf directory, you will basically have the same Hadoop env.sh, and then you will set up the core side to point to tell this job tracker where the name node is. So which will again be nn1 cluster 1.com. And then this node does not really have a lot with HDFS, but if you have set up some parameters like replication factor and block size, they go on HDFS site. So right now we have set the replication factor is 2, and we are saying the block size is 64 MB. And rest parameters, I will show you once we start looking into this. And the main thing, that main file for job tracker is map-ret site, because job tracker and task trackers, they form the MapReduce engine, right? So map-ret site will basically tell the job tracker location, like core site told the name node location. So here you just type the host name of the job tracker and type the port, the RPC port for job tracker, which is 8021. So now we have job tracker configured. So similarly, you can do Hadoop daemon.sh start job tracker. So that would start job tracker. And we can now go here and look at job tracker web UI, which would be 10.0.0.14 colon 50030 slash job tracker.jsp. So once that job tracker comes up, then you will see this UV. So this is now basically a pseudo distributed mode where I have name node running on, sorry, this is fully distributed mode, pardon me. So the name node is on this host, data node is on this host, job tracker is on this host. So this is how you will have in production. You have different hosts for different daemon. So name node will be configured on name node. You will specify the parameters for name node on this host. Data node will have the parameters for data node. Job tracker will have the job tracker. And this data node will also run the task tracker. So basically you will start task tracker on the same machine. You will say start task tracker, and then it will start your task tracker. So task tracker also comes in. So this is your fully distributed mode. So these are the three modes that you basically run Hadoop in. So Mohammed is saying, can you show in config you mentioned the name node FS? Can you show in config you mentioned the name node FS? I'm not sure what that means. I showed the configuration for name node. So core site is basically the location where you have, so under home, Hadoop conf core site is where you specify your name node web URI. So Sumati is saying, so when data node comes up, does it read the core site to find the name node? Yes. So data node will read the core site, and on from HDFS side, it notes the, so if we go look at here, home Hadoop conf core site. Core site is where it tells where a name node is, and the HDFS site is where it knows where it needs to write its data, which is dfs.data.dir. So what's the real significance of these XML files is what Shripal is saying. So Shripal, so first you configure these files, and when you start this daemon, then based on the role that you are starting, these configuration files are used. So when I said Hadoop start data node, then data node read Hadoop env.sh first of all to find the Java home, the heap size that it needs to run as. Then it went to core site to find out the name node it need to connect to. Then it went to HDFS site and find out what data directory it needs to start writing the data. So these are like the configuration files for data node daemon to use when it runs. So how does it work to Hadoop to identify the data? Shripal is saying, so basically now we have started data node, name node, right? And now if you correlate this with what we covered previously, that when you write a file, so when I did Hadoop, when I did this command here, put, this is basically I'm writing a file. So when this file went on HDFS, so Hadoop basically found out this data node available, and it wrote that block, sent that block to that data node. The client basically sent the block to that data node, and then it got written on HDFS, and then we basically could see this block under this name node, and we saw like the block count increased, so we got 2 blocks. So this is basically the significance of the config files, that they bring your daemons up, and then your Hadoop system is now up, and it will start working the way it is supposed to. So Syed is saying, as you said, so on 3 namespace ID should be same. Yes. So everywhere namespace ID would be same. Data nodes, all the data nodes and name node would have the same namespace ID. So Mohammed, looks like you have some questions on setting up the cluster. So I would say that maybe you can basically open a support ticket, because now we are going to go with the flow of this presentation. We are not going to look at individual issues, so that everybody should not get interrupted by that. So if you have questions, I'll basically request you to open a ticket with our Hadoop admin support, and they will be able to fix with. So Ashok is saying, what is JT1? So JT1 basically is just the name that this shell is just showing for it. That's basically the short basically name for this job tracker. All right, so now we have covered all these options. So basically all these configurations. So we are going to go through. So whatever I just covered in demo is going to be now shown in the next few slides. So we are quickly going to review this. So configuration files that you have to set up is Hadoop env.sh first of all the environment variables. Core site will have core settings, which will include the name node name and other configuration settings, which we will see as we basically proceed in our course. And for HDFS site, we'll have configuration for data node, name node, secondary name node, and their locations where they are going to store the metadata in case of name node and store the data in case of data node. MapRed site will have configuration for job tracker, task tracker, and then there's a file called masters and slaves. So let's quickly look at that also. So on name node, basically under home Hadoop conf directory, we have something called masters and slaves also, right? So in masters, basically you specify the secondary name node. So if your secondary name is sn1.cluster1.com, you specify the host name of secondary name node, and under slaves you write the host name of all the data nodes. So if I say dn1.cluster1.com, if I have say another data node, all the data nodes that I have in my cluster, I will basically make sure I write them here. So what masters and slaves is used for is that, because if you have say 1,000 node cluster, like I went here and I started the data node, you cannot do that on 1,000 node cluster, right? So Hadoop provides this script under the bin directory home Hadoop bin start all .sh, right? When you say start all, it will look under masters and start the master, go under slaves and start all the data nodes and all the daemons that are basically configured in this on this machine. So that's basically the use of this masters and slave, that in a production environment it's not possible to go to every data node in a big cluster. You basically specify the slaves here and just say start all and stop all, and it will basically start all the daemons in the system. So that's the purpose of masters and slaves. And so core configuration files we saw today were core site.xml, HDFS site.xml for HDFS. For MapReduce, it's mapred site.xml. So when I say when we say HDFS, it means name node and data node. When we say MapReduce, it means job tracker and task trackers. So these are some examples. So we HDFS site, you can also specify DFS.replication factor. So like we did DFS.data.dir, DFS.name.dir, you can specify replication factors. If you don't specify, by default is 3, but if you want to change it, you can make it 1. And core site, you specify the name node URI, which we did. So and then in HDFS site, you specify data.dir that we did today. For the data nodes, the list of directories where data node is going to store the blocks. And similarly, there's something called fs.checkpoint.dir. This is used by secondary name node. So we are going to cover that in our next session when we do talk about the secondary node. Today's session is basically make sure that we are able to set up clusters in different modes and basically understand how configuration is done and how you can bring the systems up. Now, configuration tuning and more details about configurations is something we are going to cover in our future modules, because this is our module to see understand basically how you can configure Hadoop and how you set up Hadoop. And so many things. So start all can be run only from the name node, right? So place where you define your, so basically you have to set up passphrase-less setup, right? So name node should be able to SSH to all the machines and run basically the command. So you have to set up that SSH from the node, passphrase-less setup, uh, passphrase-less SSH setup, and the node where you have that, from that node you can basically run start or stop. It does not have to be name node, it could be any other node also. So where you think one master and many slaves, right? So master means only, so as you have seen that for HDFS master is name node, for job MapReduce engine, the master is job tracker, right? So there are two masters, and then secondary name node is also a master, and slaves are for HDFS system. Basically, slaves are all data nodes, and for MapReduce engine, all the slaves are task trackers. So we are definitely going to have multiple nodes and multiple slaves. That would depend on the number of nodes in your cluster. If you have 20 nodes, basically those nodes are slaves or they are data nodes. They are data nodes and task trackers. So Mohammed is saying, so you mean we only need to start everything from name node? So as I just explained in Sumati's question, the place where you have passphrase-less setup, we'll quickly look at that also. That's the place where you are going to basically start the name node. All right, so Mohammed says there's no need to log in into data at all. Right. So once you have your start all script, you don't need to log in unless there is some issue with the data node and you need to look at data node logs, because that you cannot do from another machine, right? So if you have to look at data node logs for some issue, or data node you just want to see if say drive gone bad or something, then you have to log into data node. But for start and stop purposes, you won't have to log into data node. And MapRed site, as I said, we specify the job tracker name, host name, and the IP. So job tracker runs on 8021 RPC port. And these are the properties that we define for job tracker. So again, we are going to discuss these in detail. The basic one that we need is mapred.job.tracker, where you specify the name of the job tracker and the port, the RPC port that it uses. So more detail on configuration files, you can basically read from here. So these are the main three configuration files that we discussed today. So you can read from there. So we just looked at slaves and masters. So all the slaves would be the host where data node and task tracker runs, and master would be mostly just secondary name node. So Hadoop env.sh is the place where you're basically going to set up your Java home as we did, and you also can specify a lot of other parameters, like we did export Hadoop underscore heap size. So you can say heap size for data node, heap size for task tracker, heap size for name node. So this is the place where you will define the environment variables for Hadoop. And there's also something called Hadoop metric start properties that we'll discuss in our further, which is used for reporting. So we'll look at it in our later slides. So as we have seen, the critical properties are basically fs.default.name, which is the name node URI. Then tmpdir, if you don't define, it goes under /tmp, where you saw that I didn't have the permission and it failed to come up, right? So /tmp is by default. You can also change it if your /tmp is small, because a lot of in production environments /tmp is usually a small mount. So they move it to a bigger mount because /tmp is needed a lot. As we'll go along the course, you will see. And for MapReduce engine, you have to specify the job tracker name. So these are the critical properties. So these are the like minimal properties that you need to get up your cluster. And pseudo cluster mode demo that I just did. Basically, we had basically everything on one machine. And then we looked at the web URIs, and we are also going to continue this further. So we looked at the name node web URI. We are also going to look at job tracker, task tracker, and data node in our future sessions. And let's quickly look at Annie's question. She's saying, which file is used to specify name node heap size? So any guesses, people? I think this should be very easy. Two, right. It's Hadoop env.sh. Is it necessary to define all properties in core site HDFS MapRed and MapRed site? Is it necessary? No, you just need like basic minimal properties that will you need to just get the cluster up, and because other would be all tuning. Standalone mode uses default configuration, true or false? That's true, because in standalone mode you are not configuring anything, you are just running Hadoop commands directly. So next is passphrase-less setup, right? So when we say that we can do a start all script or stop all script, what we do is we set up a passphrase-less setup. So let me quickly show you how to do that. For example, if I want to say from data node, I should be able to say log into name node. So what I will do is I will go on data node, or let's say I want to start from data node, from name node, I want to basically be able to do SSH to data node, right? So what I'll do is I'll do, I have to run a command called SSH key gen, and I have to generate my SSH keys, and I'll say SSH key gen -t RSA, and I just press enter for everything. And now when I look at it, I'll go to my home directory, and it has created a folder in my home directory. If I do ls-ltr, I don't see it because it's a hidden file. So for hidden file, I have to give an option A. It will show me a hidden file which are dot files. So now it just created this .ssh. So I go under .ssh, and you will see that I'll have my SSH keys here. So I'll open my RSA public key, and I'll copy this key, and I'll go to my data node, and I'll again go to data node home directory, and I'll go to its .ssh. It might not be there because we don't have, so it's already there. So I'll go to .ssh directory, and then I'll create a authorized underscore keys file, and I'll copy the name node public key. So that means I'm telling that whenever name node tries to SSH to data node should let it basically authorize it to continue. So now when I basically do SSH to Hadoop at 10.2.10.0.0, sorry, my IP was Hadoop at 10.0.0. Sorry, I didn't look at my data node. So let's look at my data node IP, which is 14. So when I do this, now it is asking for password. So basically, once I set up the authorized keys, then basically it won't ask for the password. So what I'll do is I'll take the id.public and I will copy it to NN. So now if I do Hadoop at 10.0.0 dot say 13, So basically that's a setup. So you can try it on, and so that's how basically you basically set up your SSH keys. And another thing is I have to do is I have to make sure that I have the right permissions to this authorized keys file. So which is 600, which is fine, right? So that's basically that's what you do. Basically you get the public key and you copy it on the host for where you're trying to SSH, and under authorized keys you copy that key, and then that host basically will authorize the SSH to that host. So that would be basically, sorry. Right, so I was just trying to see. Okay, so let's look at some questions. So Rajkumar Singh, you have mentioned tempdir will be /tmp if not defined. So is the /tmp on the root dir of the Hadoop? Yes, so /tmp would be the directory where basically that host is there. So data node would be /tmp would be the root dir directory on Hadoop. Yes, so that's why you see that when I do Hadoop fs lsr, the /tmp directory is created here. Right? So it will have the user per user directory. So like right now it has Hadoop users directory, and all the temporary files will go there. So Shyama is saying anyone is experiencing delay of video? No. Okay. So Mohammed is saying about SSHD config. So it looks like we need to change that configuration also, but that's basically the idea of doing the password slash setup. So basically you set that up, so which we just looked at. And if it's not set up, then your daemons won't start, and name node will not be able to basically do SSH, and you have to enter password like I had to enter right now. So if you say which of these, oh, that's Annie's question. So let's see which one is the right. Hadoop daemons won't start, only name node will start in master. User's password has to be entered to start every daemon. None of these. So any guesses? Second. So Sumati is saying second, and Muhammad is saying third, and Santosh is also saying third. Right, so I think it's third because you have to enter the password. So now let's look like at a cluster configuration setup. That's I think Rajkumar or somebody brought, Santosh I guess brought it up, that we want to see how the configuration looks like. So let's look at this Facebook cluster. So what it looks like it has two major clusters. One cluster is 1100 machines, and each machine has 8 cores, and it has above about 12 petabyte of storage. So that's a big cluster. And there's a 300 machine cluster which has 24 cores, that 2400 cores. That means each machine has 8 cores, and it has about 3 petabytes of storage. So these cores are basically the ones that are going to decide how many mappers and reducers you are going to use. So if it has 8 cores, as we discussed yesterday, that you might say, okay, 5 mappers, 2 reducers, and 1 data node, 1 task tracker. So that's how the configuration. So we'll see that in our machine. And then we say each core node has 8 cores and 12 terabytes of space. So again, this is a commodity hardware. And they use streaming that we discussed yesterday. They use Java APIs, and they also have Hive, which we'll discuss in our further classes. That Hive is a SQL kind of engine. So, and then cluster architecture we saw today was we have masters, we have name node, we have job tracker. Master runs on 50070 web UI by default. Job tracker runs on 50030, and on slaves we have data nodes and task tracker. So every slave node will run a data node as well as a task tracker. That we did today in our distributed setup. And in the cluster architecture, if we see that we have the client, and then we have HDFS engine, we have MapReduce engine. HDFS engine is owned by name node, and name node will have data nodes, and MapReduce engine is owned by job trackers, and job trackers will have task trackers. And but since we are saying that machine on every slave machine we run both task tracker as well as a data node. So in job tracker, task tracker is up because job tracker is interacting with task tracker, but on the name node side, data node is up because name node is interacting with data node. And we look at some network configuration. So it's just added for people who are enthusiastic about the cluster. So while it's saying can data node and task tracker be on the same machine? So while that's the common configuration, that data node and task tracker are usually on the same machine. So Mohammed saying, do we need to install or download Hadoop on data nodes also? Yes. So that's what I said, that on my machines, I already did all the steps that we did on single machine, basically download Java, download Hadoop, set up everything. So on every machine, you have to do the same thing. And then you have to set up the configuration files based on the role. So if you see here, now we have different racks. So on one rack, we have have name node, secondary name node, job tracker. On rest of the racks, you have slave nodes, and then you have switches on each of the racks. And on the top, you have basically the top router, which is, and then the gateway node client, which is going to talk to name node and get the location to data nodes. So you can see that client also have a route directly to the data nodes because it is going to interact directly with the nodes in the cluster. And this is a sample network configuration that you have the nodes, then you have the switches, and then you can see that each of, and on the end you have a 10 gigabit Ethernet uh, cluster connector, and that's called a spine or a backbone. So you can see that each of the switches is having, for redundancy, talking to is connected to multiple such spines. And then on this end, basically this is, you can see that these are teamed, right? So if say this machine has one NIC card and there's another NIC card, so it can be teamed together to basically double the, basically the Ethernet speed and the data movement speed. So every rack will have like a switch, and then when data moves from here, it goes via this route, and then you can see that these are like 100 gigabit network. So usually that's what is recommended for Hadoop. Sorry, not 110 gigabit network. So that's what everybody is going. People used to start with one, but nowadays everybody uses 10 gigabit network. And then multi-node cluster, we look at the demo also, how to start every node on every cluster. So I would encourage each of you to try that. So that would be, I guess, one of your assignments for this week. And then for further reading, you can look on these documents about Hadoop cluster setup, Hadoop cluster configuration, Hadoop on Amazon AWS. I think that was Sanjay's question. Can we do that? So Praveen is saying, do we need to configure RAID on each data node? No, because data nodes are commodity hardware, and we don't want RAID there because data nodes are just going to store data, and you have multiple copies of that data on the rack. So we don't need RAID. You can have RAID on name node where you are, say, for example, storing the metadata at multiple locations, right? So in that case, you can have RAID, but on data nodes, you don't need RAID. And that was another question. I forgot the name who asked that what was the configuration of each of the nodes. So let's look at this. So name node, as we said, it would be it has high memory requirements. So it will have a lot of RAM, and it does not need a lot of hard drive. So it could just go with like say 1 terabyte space. And processor, we are saying 8 cores, but it can even go with less of that. And Ethernet is 3 times the 10 gigabit connection. And we are saying 64 bits CentOS. So that's the name node. And data nodes, you can see they might not be high on RAM, but you will have a lot of hard disk on data nodes because data nodes are supposed to store the data. And usually we'll see that you'll have multiple drives. So in this case, we are saying we have 6 drives, each of 2 terabytes each. So data nodes are storage intensive, right? So that's why they are more inclined towards having better storage. So this hard disk is say 12 terabytes, but name node has just 1 terabyte because name node is only storing metadata, which is usually in gigs. It never even reaches terabytes, but data node will always store data in terabytes. And processor, it says 2 cores, but usually it will be like dual quad core, and it would be like 10 to 12 minimum cores on data node. And secondary name node will have similar configuration as primary name node, and it could have even less sometimes, but usually people keep it same as primary name node. So in case, basically, the name node, in case say this machine goes down, and then secondary name node basically you can copy metadata from say an NFS location and basically bring this machine up as a primary name node. It's not a hot standby. So it won't come up by itself. You have to basically copy the metadata, and then you have to basically start the name node process manually. So for that reason, a lot of times people make it like same configuration as name node. And if it is just doing secondary name node, then usually people make it less RAM, as we see in this case. It is not having a 64 gigs of RAM as the name node is having. So those are basically a typical configuration in terms of memory and hard disk and processors. So when you look at the Hadoop cluster, you will always start with a single machine. You might have a local, you will have a pseudo distributed mode. And then once you are doing a POC and you see, oh, Hadoop works for me, then you'll set up a small cluster where you have fully distributed mode. You start initially with 4 to 6 nodes. And then once you see that your data size is increasing and you have so many users who want to use Hadoop, then you'll start planning on the large cluster. That's when you will start looking into replication factor, number of cores, and performance tuning, how much memory is needed for each task. So those are the kind of things. So we are going to usually mostly concentrate on this part in our future modules, like what a large cluster looks like and what kind of parameters should be tuned for a large cluster. So that's what would be our basis. And then for assignments, I guess whatever we did in today's class, I would like each of you to try that at home. Basically download a virtual machine, VM player or VirtualBox, or try it on AWS and try to install a multi-node Hadoop cluster. And then you can also review the questions, and then you can go to LMS as we did today, and we looked at that document. So you can probably use the same document, and you can look at this Hadoop installation. And I think each of you should try this, and you should definitely have like a fully distributed cluster up by your next week's class, which is the I would say the biggest assignment for this week's module. Yesterday we didn't have major assignment, but this is going to be your main assignment. And I would thank all of you, and then I'll quickly look at the questions. So Val is saying, how many data nodes? Do we install a download Hadoop on each data nodes, and how many data nodes? How many data nodes would depend on what you want to do with your cluster whale. So if you are just setting up a test cluster, you might start with say 1 or 2 data nodes, and you need to make sure that your replication is also based on that, because if you say minimum replication as 3, then you will always have under replicated blocks. So let's for example look here. So now we have 2 blocks, right? And I said my replication factor is 3, but now I don't have 3 nodes. So that means my 2 nodes blocks don't have 3 copies, and there are under replicated blocks. So that's something that all of you should see, that this is the under replicated nodes. So this is almost like one data node went down, and now name node has under replicated blocks, and it is trying to copy that to somewhere else. But because I don't have any other nodes in the system, so name node is just telling me that you have under replicated blocks. I don't have any place to keep 3 copies of the block because only 2 nodes are up. So let's look at some more questions before we wrap up. So Ryan is saying, how do we get wget via yum? Yes, so you do yum install wget, so you should have that. So Praveen is saying, typical, what would be an output from Hadoop client perspective, sort of a graph or something, actual end user output? So basically, Praveen, that's something that will become clear once we discuss about the MapReduce engine. So basically in Hadoop, you basically submit jobs, and Hadoop jobs are in terms of like input directory and output directory. So in input directory, you'll have all the files that you want to basically use as input, and they will basically be converted to blocks, and they will become input splits for the job. And once the job runs, it will again output direct data in the output directory, and those will be the again the output files would be there. So it would depend on use case to use case. For example, yesterday we saw that we had a file where we counted the number of unique occurrences of each word. So based in real world scenario, people might have different use cases. For example, some social media company would be looking at that, when I get all the logs, from the logs I want to see how many page views a user did, how many clicks a user did. So they will basically, by username, they will create output. So it would depend. For example, for a company like finance company, they might look at how many transactions this user did. So they will have a MapReduce program which will scan all their transactions and find out the transactions which are below a certain value. They will output in new directory, who are basically say in US region, output those transactions, and they'll basically group data by US region, by say Latin America, by Asia Pacific. So those are kind of jobs that people will run. So it would be different kind of jobs based on different scenarios. So if we have no more questions, then I guess we are done. So now we are going to meet next week. So I guess you guys have a lot of things to do this week. So I hope you all have a good week and you try to set this up and see how this goes for all of you. So with that, I would say we will wrap up today's session. So thanks everyone. And then we'll meet again next week. And then there's one more question by Ryan. Should any services be started on lab 1.cluster1 like nbind or something? So the services that I did, whatever I started today, I think those should be good enough for you. And one more thing that you can do is you can set up name server. You can set up a DNS and use static IPs instead of the 10.IP. So you might use like 192 kind of IP. So you can try that. That's there in the LMS document. So you can try that, or you can just follow what I did. Yeah, it's resolve.com, right? So the name server, you can set up like a name server and domain server. So thanks everyone. And Ashok is saying, I'm looking for a class open to speak. So Ashok, yeah, so if you have doubts, I can basically unmute you, but the way this class works is that usually people are on mute and I basically look at the questions and answer each question. But if you are like really confused with something and you think that you're not able to talk, then you can ask me to unmute you and you can basically talk in the class and everybody can basically hear you and we can discuss that. But usually we go with this kind of procedure where everybody stays on mute and the instructor talks, and so that because we have a limited time period, so we need to make sure we cover everything, because otherwise it might just become like one big discussion on just one slide and we not be able to make progress and learn everything. So Ashok, I would ask you to talk to our admin, open a ticket with them and see if they are able to answer your question further. And Sumit is saying, do we get the quiz answers? Yeah, I think you should. So if you don't get it, you can again, I mean, if you have any query, I'll feel free to open a ticket with our admin support, and you can also CC me. And if I have input, I'll be able to help you. Sure. Okay. So looks like we are done with the most of the questions. So I guess that's it for today. So I hope everybody got to know a little bit more about Hadoop cluster setup, and I think there's a lot of food of for thought for each of you, and try it up. And in case you are stuck somewhere and you're not able to proceed, feel free to open a ticket with our support system, call them, and you can get them CC me on that ticket, so I should also be able to look at it. So hopefully you guys will be able to set up a cluster, a fully distributed cluster, and see practice all the modules and things that are present in LMS, and then we'll go from there from next week. So thanks everyone. Have a good night and good day for people who just started the day. Bye now.